Welcome! After 2 weeks of break, I think we are back with another stream. Yeah, got a bit sick, but yeah, fully recovered by now, I guess. And there is a lot of work to do. So today we continue working on the V0, and I kind of decided to make it like part of the official build series of the V0 we started like 2 years ago. Um, because it's quite a big step. So let me quickly check everything is working. Yeah, seems good. So basically, we want to convert that machine or this machine to Canvas, and it's actually something I planned for quite some time, or want to do quite some time, because it's yeah, I really don't like the current Toolhead board. Mainly for two reasons. The first reason is I absolutely dislike the plug that comes with it. Um, I'll show it in a second, but like, it's really hard to unplug and replug, so it's yeah just painful to work with. Um, I actually had one of these cables break, which I'm not quite sure if there was like a user like an installation error or if it was just a bad cable. I had a Raven Keeper. But yeah, like I had I think three cables break from the plug. Basically, it was just like a bad crimp. And I think the way I installed it put a lot of pressure or strain on those crimp pins. So I had a couple of these like cables break. And then the other part is, and it's actually also like quite a pain point, is for the input shaper, you have to connect this like super annoying little tiny white cable here. And it's like super flimsy. You cannot leave it on the tool head because like it's like getting stuck in the belts and everything. So every time you want to run input shaper, you have to technically open up the machine on the back, connect the white cable on the Raspberry, run the cable to the front, and then connect to the toolhead board. And it's just like, yeah, super annoying. And I usually just have it like plugged into the Raspberry and then like flopping around here on the back, but still like sometimes gets caught in the belts. It was really not like a good setup. So today, Canvas. It's the exact same Canvas setup we have on the Poor Man's XY. So it's the EVB 36. They're quite cheap actually. I think it's like 15 euros for this toolhead board. So it's, yeah, basically no brainer, especially if you make a new build. It's basically the same price as like one of the dump toolhead boards. And for Canvas connectivity, we use this Physect CAN adapter. And it's also exactly the same as we have in no, it's the same we have in the switch wire. And the switch wire, I use the same one. So not a lot of new hardware in that sense. So hopefully everything goes super smooth. Um, while we're working on toolheads, I also have the CNC machined toolhead mount basically for the x-axis. Something I wanted to swap out as well, because there's like it's not like a lot of flex in the toolhead mount, but I think like from all the parts I have on the V0 at the moment, this is like the most flexing one. So yeah, these are also like not super expensive. Let's see if we can like swap that in on the fly. But thinking about it, maybe we do that next week because I really want to have the machine in a working state after the stream. So I think it's good to like kind of like keep the scope scope small. So let's just ignore what I said here and just put it to the side for next week. Yeah, we also have the mount basically for the EBB 36, so we can put it on the machine properly. And then last thing before we start doing fun stuff, this I printed yesterday on this V0, so it's actually like working really well at the moment. So I spent some time tuning that the last couple of weeks. I'm still struggling with the first layer a bit, like it's not super consistent. But overall, like the print quality is amazing. I figured out, like, not sure if, I mean, if somebody sees it back to back, like the last stream, we had a lot of issues with the input shaper on the y-axis. Turned out there were just like a couple of loose screws on the motor mounts that just like rattled loose over time. So I tightened these and everything worked perfectly again. But yeah, you see like there's really like no print artifacts. Like it's like super nicely stacked layers here, like super consistent. The only thing you can complain about, you see it here, there's a bit of like VFA on this like one surface for whatever reason. Like there's no VFA here. It's only on this surface here. And I think also, yeah, here you can also see a bit of VFA, but not as prominent. So this is like the only like thing that I would look into maybe, but yeah, VFA is VFA. It's also like not much you can do. But yeah, overall like really nice print quality. And then for people who like watch the live streams I make, this gear here I use. Oh, this by the way is a wristwatch extruder for a future project. Um, this is the gear we tried to use on the poor man's Core XY, and it didn't work because it didn't fit in the mini stealth burner. Funnily enough, like I just like used it out for trying it out, and it works perfectly here on this can't say that, wristwatch extruder. So yeah, overall, I hope this prints just as well when once we're done. But then let's get started. Enough talking. There's also something I still need to like figure out with my streaming setup. Like I have the light exactly above, but then like all like the reflective surfaces just show like the light. Let's just remove it. So let's get rid of the filament. Let's just park this back here for now. And oh yeah, the machine is on. I wonder what's the best order of things. So we can first do the hardware. Yeah, let's just start with the hardware. So I switch it off now. So I would say let's start with the toolhead itself, maybe, and then just work our way back. Okay. Let's just start with some cable ties, and yeah, this is now already the first spot or like point where I really dislike this standard toolhead mount. It comes with the LDO kit. This cable is like absolutely impossible to remove. I mean, you can say this is a positive, but like, I feel like I have to like completely yank on the tool head to remove that. And I also feel like I'm almost breaking the cable because like once it comes loose, like you pull with a lot of force on the cable. Let me see. I think like let's just take off the tool head completely. I was like considering whether we can. Yeah, but we need to do the cables and crimping, so let's just completely remove that. It's gonna get in there from behind. Yeah. Then there's the hidden screw. Okay. Let's move it over here. Oh, I know what I forgot. Shit. I was like, I felt the entire week like I need to print something. I wanted to print something and I forgot. And I wasn't sure what it was. I wanted to replace the stupid panel clips, or like the panel clips with like the ones that don't need screws. I wanted to print them. Well, now it's too late. Then I guess next stream we do the X carriage and that. For example, would be like a good workload. Okay, let's see. Let's get rid of these screws. Oh, I have one more thing for next stream. I almost forgot. But looking at it now. So next stream we will also replace the Revo heatsink here with the Revo PZ probe, because I started using multiple different beds on the V0 here, and every time I switch beds I have to readjust the Z offset, and it doesn't really quite work the same. Like, it's not exactly the same Z offset whenever I switch the bed, which is a bit weird, but I figured having like a probe does not hurt at all. Do I have to? Yeah, let's remove these cable ties here, just like to give us like a lot more work to move a little bit over here under the camera. Okay. Grab my. Hi there, Steve. So let's first unplug everything. I think it's easier to unplug while it's still on there. Then we need to check like which plugs we need to recrimp, which I think will be quite a couple. Because I think actually we might get lucky and we don't have to recrimp a lot. Hi there, Harlem. So just apart fans EVB only has one plug, not two, I guess. Yeah, I think that's one thing we definitely need to do. But let me check. Are they? Yeah, they're separate at the moment. Yeah, yeah, you're right, Steve. So these two definitely need to go on one plug. And crimping two cables onto one JST connector is one of my most favorite things to do. So we will have some fun. And I think this part we also don't need anymore. Actually, like one thing I really like about this tool head or this board mount is like it puts the board at an angle, like it's slightly angled backward, which I think is better for the cable to exit at the angle. And this one is just straight up. So, but this one has a strain relief, which is a big step up. As I mentioned, basically from that original cable, I had like multiple like cables break on the first cable I had, which yeah, the crimps were not perfect. But also there's like no strain relief on this machine, which is a bit weird. But yeah, after the cable was swapped, like I never had any more issues for like, we checked last time how many hours I had, but I think it was like a bit over 1,000 or around 1,000 printing hours. And that was the only real defect I had on the machine, so that is quite good. Okay, let's see. So I think we can basically just put this on straight away. But looking at this, what confuses me a bit is like these two holes here. What are these supposed to? Oh, interesting. Well, looking at the V0, there are two more heatset inserts here on the back. Interesting. Because the old mount, I mean, I knew they were there, but we never used them, right? Like the old mount only has the two screws that connect to the motor, but the bottom two are unused. So the new mount will make use of all four mounting positions. which also means, also looking here at this CNC version for a second. So basically it's like these two screws on the back. So this will later, if I just put this here quickly for like demonstration purposes, will be later looking like this. Oh, wait, let me adjust the camera a bit. So this will later be looking like this. So we have it connected on the motor and on the bottom too. The important part here to check is like there's actually like this little cutout because the motor cable, standard, if you build the mini stealth burner, they expect the cable of the motor to be on top, but I don't like that visually. And there's enough space to have them on the bottom. But then with this Toolhead mount, it still works out because there's like little space for the cables to come out. And I think we also have enough. This might be a bit difficult then to reach. Okay, let's see. We'll try it out. We'll try it out. Let me get this out. And let's just steal the screws that were used here, which are really long screws. I guess we can keep the tool head mount for now. But also, how do we then mount this? Like, because now you like before it just slid on, but now you have to kind of like hook it in. Let's see, will be interesting. If these like mounting points annoy me, we can just snip them off and ignore that they were ever there. But I don't think we really need them because like it's securely mounted on the motor here. Like this is not a really like it's really stable. It's not going anywhere. Okay, let's see. I think it's also smart to like undo this cable tie here. I was a bit scared that I accidentally snip a cable. These cables. Let's remove all the cable ties. Because the cables need definitely be rerouted in different spots. And that is easiest if we don't have any random cable ties. Okay, here we go. So then we can also like pull apart what we have here. Okay, so I mean this one we can already connect. That's the hot end. So I would also try to avoid recrimping them. We definitely have to shorten them a bit. Oh no, it looks quite good. Okay, Just need to make sure that they're like routed a bit differently because I kind of want to have it on the outside here. Then the motor. Technically, we can also, so we can leave it here in the middle, or I'm thinking whether we route it on the side here. And we do it like this. And also, we shouldn't forget the cooling block for the stepper driver. Flash it now will be easier. Yeah, I think we should definitely flash it. Let me just put it together hardware-wise, but then before we put it back, we should flash it. Although I think flashing it might not be too horrible because USB-C port is quite accessible. Let's do this first. Okay. Then, as Steve already pointed out, we need to put both part cooling fans on one plug. So these two need to be combined. Then we also need to quickly check the pin out. Let's quickly open that. Let's just put that here on the side. We have it for quick reference. So that means we have the thermistor going here. That one is easy. And then we have two fans, which are these two ports here. Another thing is we need to have the lights. We do have the RGB connector here even. So we need to not recrimp, but we need to replace the JST plug here. So we have on these three, we have 5 volt, then one GPIO pin, and then ground. So I think, yeah, we just put it on 5 volt and a GPIO pin. And it's the same setup that we had before. Before we reused the Z end stop pin to drive these two little LEDs. But then basically now let's just use that RGB header. And then the last thing we need is the fans. Yeah, so crimping time. Oh, of course, put it in the most difficult spot. So let's start with the LEDs. I think that should be quite easy and quick. I just hope we can reuse the pins. Yeah, this one is good. That one is a bit stubborn. Here we go. Okay, and then we need I always use a knife to go under that little like nose of the pin, and then you can just push it back out. And then you can reuse the JST pin. Like you can do this a couple of times, but not all too often. So the 5-volt needs to be on top. And the ground is in the center position. And the ground will basically go to the GPIO pin. So then this goes here. Then the part cooling fan, the hot end fan is this one. I think it doesn't really matter which fan header we now use, so let's just use this one. And these two need to be recrimped. So let's just get them out first. Okay. I'm only trying to get them out for like a hot second. Okay, here we go. That can go back. I want to cut them quite short, so I first want to remove the housing. We don't have to be super careful with the pins here because we're not going to reuse them. There's this official tool to remove JST pins, and I'm kind of feeling I want to have that because I remove a lot of JST pins and it might be easier. Okay. Let's start with the LiPo ones. Hi there, additive add-on for this kind of conversion. So the Toolhead is just the mini stealth burner, so standard for the V0. The board is EBB36, and for the CAN connectivity, we're gonna use this Physact CAN adapter. So that's the hardware. It's actually not super expensive to do that. Like all the hardware is relatively cheap. I think this board you get for like 7-8 euros. The EBB36 is 15, so it's like 20 euro, 25 euro thing in total. And the big benefit is that you have way easier input shaping, and you get rid of that annoying LDO cable. Okay. Crimping 2 cables in one JST is always fun. I think I need a little bit more bare wire here. No, you have to cut them quite short or like expose very little wire for JST. I think because we're twisting them together, we need like a bit extra reach. Okay. Yeah, now it's too much. Let's just take off the tip. Is that too much? Oh wait, that's a... Oh, that was a used one. Okay. Now always I just squeeze it a bit together that it holds on, which it does not. Yeah, it's not a good crimp here, but it seems to hold on. So. This is a good crimp. Here, like the... Oh no, it's not a good crimp. Shit. I was too optimistic. Not sure if you can see it on stream, but like this slipped out. So now it's only crimped on the isolation of the right wire. It seems to hold, but I want to do it properly. Let's give this another shot. So basically what you want is from these JST crimps, for actually quite a lot of those crimps, part of the connector is supposed to crimp directly on a bare wire, of course, that you have like electric connection. But the rear part here, so you have these wings on the back, they're supposed to grab onto the isolation of the cable. And that's basically what's supposed to have hold like onto the cable, like where the mechanical forces are basically absorbed. Yeah. So now here basically it's both wires are like the rear wings are crimped onto the isolation. And on the front, it's like grabbing onto the bare wire. And here we have the same. It's just like the wings folded in a weird way. But yeah, it holds. So good enough. Let me check. Oh, we also need to 100% check the... It's always important to check, and I just plugged it in. But it looks good. So the 5 volt or 24 volts on the bottom, and ground or like the GPIO pin is on top. Because like there's no standard basically which way around these connectors are supposed to be. So you always need to check the wiring of the board you're plugging it in. Okay, and that's it. So we still have like quite a lot of like pins left here. Remember on the old one, it's basically every single plug was used. On the new one now, we have a lot of like pins left, which is great. So first, like we technically have a RGB pin here. And here we have the end stop pins. So that the connector here with the housing, which is 5 volt ground, 3 GPIO pins. On top of it, we have the I2C, which also has 2 GPIO pins and 5 volt in ground. And on the bottom, we have a probe connector, which technically kind of the same as end stop. But yeah, this one has 2 GPIO pins and 5 volt. So we can connect a lot of additional stuff here on this toolhead, which we will due time. But yeah, this is like the big benefit also of having this compared to the standard toolhead board, because here like this is just a distribution board basically, right? There's no chip on it. It's just wire, like you get this many wires in, and this many wires you can then distribute. And for CAN bus, you see we only get 4 wires in. So you get 24 volt, you get ground, and then you get CAN high, CAN low. And that's all you get. And then we have like a little microcontroller here that then basically just does the entire logic. And that's the big benefit of these CAN bus toolhead boards. Like you can create, or like you can put a lot of hardware on the toolhead board without running like a million wires down to your main board. Okay, let's sort this a little bit. And then when this is sorted, let's start the wiring. Let's connect this one and then flash catapult here. Potentially, maybe it's already flashed. I'm not quite sure what I did with that board before. I did something with it, I think. So we might be lucky. I am optimistic and we don't need to... Oh, we 100% definitely need to crimp more stuff. I don't have to put it far away. We also need to set this jumper here. That's quite important. The last device in the CAN bus needs to have a 120 ohm resistor. And this is exactly what this jumper is doing. Yep, it is. Oh no, it's the wrong jumper. Really? Yeah, this is a small one. Check. Yeah, other ones? No, that must be it. Oh, okay. Now it fits. Is this the right jumper? I'm a bit confused. Ah, wait. This is the jumper here on the side. This is CAN out, basically. Like these 2 pins here are CAN high and CAN low. My bad. we are golden. So basically, if you, for example, have like I know, like a beacon probe. I think beacon can speak CAN, and there's also the Eddy Duo from Big Tree Tech. If you have one of these probes, then basically you can connect them here to these 2 pins. And then basically you still only have 4 wires here coming to Toolhead, but now you have the Toolhead board, plus you have the Eddy probe. That's pretty cool. So you can just connect like lots and lots of stuff there. Let me grab some cable ties. And we can organize everything again. So I'm trying to keep this like little cutout here in the middle free. I think it makes it easier later to wire everything up. So let's actually also tie the motor cables down here. Actually zoom out a bit. So all these oh, actually went through the screw hole. Oh, the LED cable is relatively short now. Ah, like this it works, okay. It's always good to have the cables on Toolhead relatively tight on the V0, because especially on the back, it's very easy for the cables to catch on something. I think if we maybe can pull these down a bit, we might be quite good already. So maybe we put a second zip tie exactly here where I have my fingers. Just to hold this a bit together. Or maybe we can, yeah, let's do it. Maybe we can zip tie that to the motor mount. We just go through here. And then this is all clean. Like these will be like kind of like pushed up here anyways. Let's do the same here maybe. Let's see if this is possible. I think the LED wires here are too short. Let's just do it with these. And that's a nice and compact small package. Perfect. Okay, then let's do what Steve suggested and do the flashing of Catapult next. Quickly put everything back. I like to reset my working space sometimes a bit, that there's less chaos. So okay. So we can turn on the machine. It's just like there's no tool head, so Clipper will not be happy. Oh, we have a lot of gunk in there. Yeah, maybe we can quickly get it out. Okay. Let's give it a second to boot up. We need to give this like a deep clean. What we can also do in parallel is we can open it up because we will need access to one USB port. Yeah, I wish I would have remembered to print these panel clips. Okay, let's get rid of this. And I think we can also just flip this machine on the back. Okay, so yeah, this is this annoying cable I was talking about for the input shaper for the old Toolhead board. So let's just take that and put it far away. Okay, then next up, what we need to do, we have USB ports here. And I don't have USB cable, which is very smart. Um, let's just quickly, we need to reroute this USB cable anyways. So on the top here from the V0, there's this like expansion board here. We gotta remove that. So basically this is where we will put the CAN adapter. The only thing this board is doing at the moment, it's doing not a lot. The only thing it's doing is the RGB left and right. Off the bat, we have these RGB strips. So this is this cable here and this one. And it's powering the Raspberry Pi. That comes in here on this like cable. Instead of powering the Raspberry Pi through the expansion board, we will power the Pi from the laser port here on the SKR Pico. SKR Pico, yeah. Basically, the SKR Pico is made in a way that can piggyback a Raspberry Pi. And this laser port, you actually get like a small cable with the SKR Pico. Can also be used to power the Pi and also technically have a data connection. But we just use the power provided by this laser port to power the Pi. And then the top board can completely go away. The only thing is I'm a bit confused about right now is that there's a stepper port here. There's a stepper plug. But I remember correctly, this just connects to the SKR Pico. There's no stepper driver on this board. Oh, and we are gonna lose our speaker, the piezo element that does the beeping. We will lose that, unfortunately. But yep, you can't have it all. Okay, let's quickly open this cable channel. I'm not a huge fan of doing this stuff while the machine is on, but it is what it is. And I hope we have enough cable later to reroute that slightly. Yeah, oh yeah, there's a lot of cable here on the side. Yeah, that's good. Because later for this board, we don't plug it in like this. Like at the moment it's like vertical, but we need to like go from the side. So I'll just unplug this. USB is always fine to unplug, I guess. Clipper's already not happy. Now it's even less happy. Gunk falling out as always. And then we need to put one more jumper. Let's actually quickly check if we have like a manual for the EBB36 that we can just follow the manual. We need to power it from USB, so we need to set USB power. So I think this is this jumper here. If I remember correctly, you need to put this jumper to power from the USB connection. Okay, let's just check Clipper Canvas guide. And there are quite a couple of good guides by now. I always forget which one I was using. Let's just go with this one. Yeah, I think this is kind of what I was using before. So the canvas boards, they're all kind of the same. This actually comes pre-flashed. So yeah. But this one seems quite old because it still says can boot, and can boot is now catapult. Steve, I trust you. Nope, I don't have a link from you on Discord. So we are not going to using this. There you go. Esoterical. Okay. Oops. Let's go with this guide. Yeah, thank you, Steve. Yeah, let's go for the new build. Yeah, let's also quickly, let me grab a terminal. And while I'm doing that, let me quickly get my laptop more in the center that I don't have to like lean forward the entire time. Um, you see, this most likely will not work. Um, Let me quickly resize that. It would have been predictable that we need to use a terminal, but I kind of did not consider that. Yeah, good enough. Let's SSH into the machine. Oh, it's a bit annoying now. The subscribe thingy is on. I'll just put it here. That's good enough. Okay, here we are. Then, oh, I also now realized the chat is not on stream. I totally forgot to set it up. Here we go. Bit weirdly positioned, but it's there. Let me have Chrome here on the side. It's a bit small, but should be good enough. Okay, then let's just start. Make sure the network service is running. Let's copy this. Okay, it did something. I have no clue what it did. Then we start the network service. We started the network service. Then check if it's running properly. It is loaded, active, running, I guess. So, looks good. Um, oh, wow. Unfortunately, this also enables systemd network wait online service, which can cause your system to be frozen for around 2 minutes on boot as it waits for network interface to be online. If the problem was only the CAN interface, there would be always around. There would be ways. Oh, there would be ways around this, but as there are edge cases where the wait would still happen, I found it's the best to disable the wait on service. Okay, let's just disable this all together. Okay. Then configure the TXQ LAN for the interface by the following command. Okay. We did that. And then to confirm, we run this. What are we supposed to see? Yeah, and the queue length is now 128, which we did set. So this looks good. Then we enable the CAN 0 and set the speed. We confirm it's running. And I think we get the output that we need. Yeah. Name CAN, bitrate 1M. And then we reboot. Let it reboot. Okay, cool. So far so good. Then while this is rebooting, let's quickly check that. So the 120 ohm resistor is what I mentioned already. So basically at the end of the canvas, you need to put that. We have this jumper set here, so this is all good. Then can hit the main board, some boards like the BTD Octopus. After this is permanently connected across the CAN high, CAN low wires, so nothing you need to do there. I just will have a 2-pin header, which I don't think we have here on this one, to be honest. I think this is just always enabled. There's nothing we can set. Nearly all toolheads will have 2-pin headers, sometimes labeled 120R, that you can put a jumper on. Okay. Cabling, all the standard stuff, good crimping, strain relief, flexible cable. Let's keep that for later. Now the CAN 0 interface is set up. You need to choose how you are going to connect your Pi to the CAN bus network. To actually create the CAN network in your system, your Pi needs some sort of device that can access CAN adapters. Simplest plug and play option is USB to CAN. This is what we have here. And we have actually the FiSect UCAN. This is exactly what this device here is. Okay. Let's quickly go through the dedicated USB to CAN device, but we don't want to set this up yet. Let's first go to the mainboard flashing section. Let me quickly check. We should be well rebooted now. We are rebooted, so we also don't have the freezing for 2 minutes. I think we have Catapult already. Oops. Do we have Catapult? We don't have Catapult. Okay, then let's... Shall we do an update upgrade? Yeah, let's just go through that whole shebang here. And it's not super interesting to watch that download. But that's what we need to do. Yes, we want to install this. While this is loading, let's quickly check out the... because this is only, like, this is agnostic to the board you're gonna use. So let's quickly check the EBB36 USB power. Let's quickly check here. This is not specific. Yeah, exactly. This is the 5-volt jumper here. So this little green thing there. So we need to set that in order for us to be able to use the board. Let me quickly grab one of these. Then I'll just put that jumper. Let's quickly check on that. Sure, I've done it before, but hey. The other thing is, when we're doing that, potentially we'll also want to upgrade Clipper right away. But maybe we can also just keep the Clipper version that I have at the moment. It's not the latest. I'm always a bit of a never touch a running system when it comes to Clipper. Like, unless there's something like I really want new feature-wise, like I always just keep the Clipper I have, because, like, yeah, if it runs and it prints well, like, there's no reason to really upgrade. Same goes for the operating system. Like, I try to not touch that as much as possible. Because I had like some case in the past where like you upgrade something Linux wise and suddenly stuff doesn't work anymore. And it's always like super annoying to figure that out, like what's wrong. And yeah, again, like this is not a machine that's like on the internet or something. I mean, technically it is on the internet, but it's not like used actively for internet stuff. So yeah, there's not really like a need to constantly update everything. If it works, it works. Yeah. But yeah, so this USB cable later will go back to the top and we connect it here. And then the big board goes out. I'm really curious how the power via the SKR Pico goes. I never powered the Pi from the SKR Pico directly. I hope this will work good. The other thing I'm a bit concerned about is I always hate powering the Pi from the GPIO headers. I did screw up once in the past where I accidentally shorted out a Pi because I plugged in the GPIO header the wrong way. So if we do that, I rather would have like a plug for the whole GPIO header, because then you cannot like put it the wrong way. If you only crimp like a DuPont connector with like 2 headers to put it on the GPIO, like you can always like screw it up. We need to check what I have here. But preferably I just like have like a plug for the entire GPIO header of the Pi. Yes. Okay. Whew. That took a second. Here we are. Then we install Catapult. Pretty sure we could also have used Kiao to install that. But let's just follow what the guide is doing here. So we're going to make menu config. Okay, cool. Let's also quickly check again on this lab4450.com for our specific settings. Oh, they don't tell us? What a shame. Then let's quickly check ABB36 GitHub. And let's see. This is the V0 1.0. We have the 1.2 or something. Yeah, so we need to check here. And we need to say enable extra low configuration options. Then we have SCM32 and then the G0B1. I don't see that enable extra low thing. But let's just select G0B1, right? G0B1. G0B1. We want no bootloader. Let's quickly double check here. Oh yeah, so we want the bootloader for Catapult. Oh wow, this looks a bit different. The menu is different. I don't see. So here in this manual, we have build Catapult deployment application. Oh yeah, no, it's the same. I'm just looking for the wrong thing. So, oops, we need the 8 kilobyte bootloader. That's the only option we have. Like the menu says 32, but it's not an option. Clock reference, we need to check the EBB, that's 8 megahertz. And communication interface is USB. But this is not correct. This should be CAN bus, of course. So again, looking in the manual, it also says here USB. So, and make sure communication interface is set to USB. Okay, also make sure the support bootloader entry on rapid click is marked. Okay, so USB is communication checked, and the support bootloader on rapid double click. Then I think that's then it, right? Enable status LED is something they have here, but they don't have it in the GitHub. So let's just keep that off. Just like one double check. So we have the STM32G0B1, which is the correct chip, STM32G0B1. Bootloader offset is here none, but we follow this guide where it is 32, but for us it's 8. Don't ask me why this is 8, but it's the only option we have. Clock reference is 8, and the communication interface is PA11, PA12, USB, which is here and also the other guide. So this looks good for me. Save configuration, yes. Check. Then make, clean, and make. Just reading ahead here, to flash, connect your mainboard to the Pi via USB and then put the mainboard into DFU boot mode. Your mainboard user manual should instructions on this. For us, it's basically keeping the boot button pressed, which is the one on top. So we have two buttons here. We have this one here. We have this one here down there, and we have the reset. No, this is the boot button, and it's the reset button. So we want to connect it via USB. I'll just check if we can. Oop. Get this USB cable out. Here we go. So I connect that via USB. And there's a little green LED telling us we have power. And to put it in DVU mode, we basically, let me just get maybe like my tweezers. You press it's kind of the same on all these devices. You press the boot button, or like hold it pressed, and then you click the reset. And now it should be in DVU mode. Yes, so let's just follow the flashing steps here. So we check ls USB to see whether we find something in DVU mode. And we see that we have it in DVU mode. Success. So just to show you, like if I now press the reset button again, I just press the reset button and we run ls USB. Now it's not here. But if I repeat the steps, so I hold the boot button and I press reset, we have it back in DVU mode. So always like hold the boot button, press reset. It's like on all of these devices the same. Okay, then we go to Catapult. We already are in Catapult, and then we do sudo dvu util. The only thing we need to check, yeah, this is correct. So you see the SCM device in DVU mode is 483 DF11, which is this one. So this was success. That's it. Oh yeah, and that's also something quite common. For some reason we don't have it now here, which is funny. But often it ends with error during download get status. Seemingly that was fixed because we don't have it here anymore. We have download done. But I remember that from all the other times I flashed boards like this, that it always had this like random error that didn't really mean anything. Okay. Then we are done with Catapult installing. Like Catapult is now here. So if we now do ls def serial by ID, we should see that we have the Catapult device, but we don't have it. Ah, interesting. Yeah, if you don't, then double click the reset button. Okay, let's double click the reset button. And now we have it. Perfect. Here's the catapult device. If you keep seeing the board but show on as Clipper instead of catapult even after double clicking the reset button, then you may have a dodgy reset button or aren't getting the double click timing correct. Okay, but that's not the case for us. Amazing. I see a very big red stop button, so let's or stop sign. Let's read carefully. If you do not see a catapult device listed, that doesn't affect us. If you get cannot access no such file directory, then your mainboard isn't currently sitting in the catapult mode. Okay, that doesn't affect us, so we can have this very big stop sign ignored. Installing USB CAN bridge clipper. Okay. Then we go to Clipper, make menu config. Can I type Clipper? We will never find out. Make menu config. Okay. So we need to set up exactly the same thing as before. So we have STM32 and the processor model is STM32G0V1. Then let's see. So we have the 8 megahertz crystal. Now the interesting part is we should check this. Hi there, Camaro 45th. I beta this Octave. I hope all is well. Thank you for testing. Actually pushing out a new beta very soon. I'm a bit stuck on some small things, but it's almost ready. Has some nice Clipper improvements. Let's quickly check here this common hardware thingy. But this is mainboard flashing. This is the wrong section. Oh wait, we are in the wrong one. Stop. Toolhead flashing. We don't want to flash our mainboard. Let's quickly opt out here. We do not want to flash the toolhead because we have our little CAN bus adapter, which is pre-flashed. Hi there, Jonas. Looking forward to it. Yeah, it's all the bed leveling magic is now in Octoapp. Wanted to do it for quite some time. Okay, toolhead flashing. I'm not quite sure how we now add it in the mainboard section because yeah, common toolhead hardware. And we are here EV36. Oh, that's nice. So we have actually like exactly what we need here. So let me quickly go back and make menu config. So we need STM, GB 8 kilobyte bootloader, 8 megahertz crystal, and then we have CAN bus on PB STM. Then we have the G0V188, and then we have CAN bus on PB0, PB1. Let me double check that is correct. Oh, I now see here that we should have said communication interface CAN bus PB0, PB1. We now have it on USB. Let's backtrack then quickly. Let's quickly backtrack. So let's change that. So in the menu config, we changed this also to PB0, PB1 for CAN. CAN bus speed is 1M, and then we can also enable the status LD PA13. Perfect. Oops. PA13. Quit. Yes, save. And then we make clean make. And we just quickly flash that again. Oh, sorry, I'm not sharing my not sharing my terminal. You're in a neighbor flashing not tooled section. Yeah, Steve, I have no clue how I ended up there. I clicked some link and suddenly I was in the wrong section. Okay, I put it in DFU mode. So ls USB. And we are back in DFU mode. So now we can just use the DFU util and flash clipper, flash catapult again. Oh yeah, now we get the error during download status, which is success. um, okay, then let's quickly hit the reset button twice. And then we should now see in serial by ID. Oh, we don't see it. Ah, you know what happened now? So now we are expected to communicate via Canvas with the device, right? Because we flashed Catapult, now with Canvas communication. So now we need to communicate with it via Canvas. Let's then connect Canvas, I guess, right? So there's nothing anymore here we need or we can do. We have Canvas, or like the Catapult flashed for Canvas, and it's actually working. You can see the little status LED here blink. Sorry, you see the status LED blinking. If I had reset, you see this is stopping. And if I reset twice, you see it's blinking again. So now we are in the Catapult bootloader. So everything is fine and working, but we now need to communicate via Canvas and not via USB anymore. So we can just unplug this. And this is ready. I also upgrade my stealth burner on my Trident to USB board once the new version of Nighthawks is out. I need a downstream USB connection because I want to run beacon probe. The beacon can also run on Canvas if I'm not mistaken. So that also is an option. I actually prefer Canvas over USB for a very simple reason. Like there's some arguments that Canvas is more reliable. I don't know if that is the case, really. The one reason I really dislike USB toolhead boards are USB cables. Because the USB cable, you get the plug you get, right? Like this is just whatever your plug is, you cannot change it, you cannot recrimp it. But the more important thing is that the cable is way more stiff compared to a Canvas cable because it needs shielding. Canvas doesn't need shielding, right? So we will just use this unshielded floppy cable for Canvas later. And I can just cut this cable to any length I need it, and I can just crimp the terminal connectors on it. And that's the one thing I really like on Canvas compared to USB. The downside of Canvas is, of course, you need a Canvas adapter if your mainboard doesn't support it. But these are not super expensive, so I don't see it as a real downside. Yeah, so that's for me. Like I'm team Canvas on that. Not saying the Nighthawk is not a cool toolhead board or anything, but yeah, for me it's just like the cables are just not really easy to use. LDO Nighthawk has basically Canvas-like cable. Oh yeah, okay. I can't remember that, but if it comes with a custom cable, then might be taking away the pain there a bit. The big benefit of toolhead boards is if you want to run a nozzle cam. Because then you have USB already on toolhead. I think, if I'm not mistaken, the Nighthawk has a USB out. Remove 5-volt jumper. Yeah, it's also a good reminder. Thank you, Steve. I would have forgotten that. Okay, next steps. So I think we can now just do like all the electronics here. Let me just quickly sudo shut down dash n. Let's dash now. I never get this straight. Okay. Well, I tried. um, the non-USB one has USB out. Okay. The more I'm looking at setting up CAN, the more happy I get that the Nighthawk now is this thing. Looks so easy. Yeah, that's the thing. Like, it's just like USB is easier. USB is definitely easier to set up. Like CAN bus, there's some steps involved, but in the end, it's also not difficult. Like, I mean, you see it now done. I just follow the manual, and that's pretty much it. And these boards are absolute no-brainer because they come pre-flashed. So there's really not like a lot to do. Okay, now the fun part. So firstly, I have no recollection how this board is mounted here. Let's first unplug the LEDs. That's the easiest. Oh, if I can get my big hands in here. And let's also remove the power. This one we can actually reuse this cable because our CAN bus also will need 24 volts. Not here, but the cable we do make will need 24 volts. Oh, this is too big. Then we have this one here, which is the power for the Pi, and this one we definitely do not need. Let's see if we can like wrangle that out under the serial connection here. So this one we don't need. What we can do technically, we can keep this little like daughter board here. You know what? Maybe we can reuse this cable. So basically this cable that's powering the Pi, right? And as I mentioned, we want to grab this here from this laser port, which kind of has like the correct length. So we can maybe just crimp a new connector on here and just keep that. So I'll just put that over here for now. Then I think we can now remove this board here. But there are rumors a new SP version is in the works. It would be nice. I think Cartographer has a canvas. Oh, yeah, Cartographer has a canvas version. Beacon does not. But there's also now the Eddy Duo, which actually is, in my opinion, the nicest Eddy probe, because it has the same footprint as the normal induction probe. So you don't need any special stuff on your toolhead, it's just a drop-in replacement. And a duo can do USB and CAN bus. Let's see. Can we, because like we need to get it out from the bottom. Can we? Yes, I think this should work. We could have unplugged. Oh, there's still the plug for the stepper motor. One thing I kind of dislike is that the Nighthawk is not really USB power delivery, but data or USB 24 volt. Yeah, well, the thing is with power delivery, they don't have a 24 volt mode, right? USB PD only has 9 volt, 12 volt, 15 volt, 20 volt. And then I think there's a 40 volt version, which is like for like if you use like tons of voltage. Ah, okay. I have to remove the the plug. Does Eddie have a good contact implementation? I am not sure about that. That's something you would need to check. But I know that the beacon or I think the beacon contact implementation. Yeah. Okay. is open source, and I think it was pulled into Clipper. So all of them should have roughly the same. I would check it out. For me, like the Big Tree Tech Eddy is the nicest hardware wise. The contact I didn't check. I'm not up to date there. Mm, once you set up 5 printer to use the EBU36, Ken is so easy for me. Well, it's number 2 for me, right? It's number 2. We are getting there. Ugh. Here we go. Yeah, so I think my plan was, I think this one we should keep. I didn't print like a replacement for that. Maybe you should have. But yeah, so this kind of needs to stay there because otherwise we have a hole. Although, let me check. Because I remember that there was a shit, of course. There was like an acrylic panel that came with the kit that fit here. And then this one was basically like the LDO specific upgrade, but they still gave you like the standard clip, like the standard Voron part. And I'm fairly certain that when I moved in December, I made the decision to not keep some things. And I think this was one of the parts I did not keep. Which would be quite a bad thing. Let me quickly pull this one cable out here, which is the extruder motor. We don't need that. If you excuse me for like 1 minute, if I have it, I know where it is. Then we can use this acrylic panel here. Let me quickly check if I still have that. If not, then we use the part that we have at the moment, which is not super perfect, but will do the job. Now I lost it. Where did I put it now? Oh, put it in here. It's good. Let me quickly see if I find that. I'm back in a second. Nope, bad news. I don't have it anymore. Um, I think like I had like from because like when I got the kit, basically the 0.2 just came out. It was like the first batch of 0.2 kits, and all the 0.1 parts came with it, including like the old 0.1 had the panels for that. And I kept the panels for the 0.1 hat the entire time, and then like now in December when I was packing, I was like, I will never build a 0.1 hat, so I just threw the panels out. I'm pretty sure that this one was part of that batch of panels I threw out. Too bad. It's a shame, but it is what it is. Okay, then coming back to this situation here. We do have now 2 things we need to check. Um, we need to power the Pi. That's step 1, right? So we use this cable. We have 24 volt here. So I think what we will do is like using this print a part here. This goes this way. So we will just put the CAN bus adapter here, and the CAN bus cable just goes out here. So we can just like put it out. Will not have a strain relief in that direction. So we should replace this part maybe next stream, but for now it's fine. And then basically we can use these cables to have 24 volts. So I would just put two Vago connectors here where we can feed 24 volt in. And then basically the 24 volt and the CAN bus can all go out here. That would be my idea. For that to work, we also, or like technically, like this is not really required, but we have the LED connectors here. I would leave the LEDs out maybe for now, and then also next stream like clean the LEDs up. We need to check where we do put them. I remember we found a spot, and I think what we said is we would use the thermistor connector here, which is just a GPIO pin. And these LED strips we put in, they run on 24 volt. So the yellow cable are 20. Oh, no, wait. The power is already connected here. Oh yeah, no, we wanted to use the fan 1. The fan 1 connector here has the power for the two LED strips. And then what we can do is we can just put the yellow cables, which is the data connection from both LEDs, and put them here on the fan 1 negative, like it's a GPIO pin. And then we just need to connect the ground. Maybe we can use that laser port there. So let's quickly check the pin out. SKR Pico pin out. Okay, so yeah, that's what I mentioned. So the fan 1 here has the IO17 and the 1224 volt. So at the moment we use the 1224 volt for the power of the LEDs, and then we can just use IO17 as the data pin. And then this laser port here has 5 volt ground. So these 3 pins we will use to power the Pi. Technically you can just do ground and 5 volt. We don't need two 5 volt cables. And then we just need to see where we can grab like another ground connection from, but it shouldn't be a big deal. Okay, let's just start, I would say. So still in very beta, I think. I know tried it on his Switchfire and it worked okay, but had some issues. Might be better on a rigid bed. Yeah, the Switchfire is not really tappable. Like it's also not like the tap probe doesn't support it because the bed is not super rigid. So I'm not quite sure how well the Eddy tap would work there on any probe. Okay. More crimping. These cables look like they should be easy to crimp. And they are easy to crimp so far. Perfect. Then we need a 5-pin housing. And looking at our pin out, it's basically like the outermost on this side. And the center one. Yeah, perfect. And then we can already plug that in. And that should power our Pi already. So that is one task down. I really wonder why LDO doesn't use that out of the box, right? Like, because they have this arguably cool expansion board. And I'm pretty sure we will use that for something else in the future. um, but they have that and basically use it to power the Pi. It's just like, not sure why they added all the stuff here to power the Pi. I mean, maybe they needed it for something else as well. Maybe for the RGB LEDs, maybe. Okay. Speaking of RGB LEDs, so this plug here has a fine length. But this plug here is definitely too short. And I wonder if we can get away. Like, we need to extend this. Yeah, that might just be okay. We can work with this. I don't want to take off the panel if we don't have to. So what I would do now here is let's just solder like extension to those two cables. Then we don't have to redo the strip. And then the question is, so basically here we would have 24 volt and we would have ground, right? Like this is like the big connection that powers the Toolhead. So if we so we need to use Wago terminals there anyway. Initially my thought was to use these and really just like basically have like one in, one out. But what we can also do is we can just use the three blocks basically. Just want to check if there is enough space because there's not like tons of space like depth wise. That should just fit. So if we do it like this, then basically we can have one in, then we have the tool head out and we have the LD out. Then we don't have to connect it to the fan port here. Then we can just have power and ground directly connected. And then we only need to run the data connection to here. Because like there's no ground connection really available. I'm not quite sure if we should connect the ground of the LDs to the, I mean, technically we can do that. Technically we could do that. I'm looking at the thermistor connector here. Because like there we have ground and we have the GPIO pin. Then technically we can leave the power here for the LDs and have the thermistor connector for driving the data and the ground. You can move the LD power to the Vagos you're going to use for the CAN 24 volt. Yeah, exactly. That's what I'm considering. Like this would just be like this setup in red, right? So we have like 2 times 3. I'm just wondering, like technically we can just leave it here. Like it's working. And we have to crimp one new connector anyways. So I would just leave that here on that fan port. Like the fan port 5 volt is like more than enough to supply the LDs. Let's just leave it there. And then we use the smaller Wagos. And we just use the two to connect the tool head. Okay, let's do the LEDs because we cannot have a printer without working RGB LEDs. Then let me quickly take the two Vagos out, and then we can like get rid of this box here again. Oop. I have some rogue belts. Okay. Then we need to solder. A bit of space. Okay. So let's first extend these two cables. I'll just use the exact same cable. And then we oh, that's annoying. Or it might just be it's just long enough to reach down here. Yeah, should be fine. So we need from here to just go with the extra bit. Okay. I have the tendency to like shift over here, but then like I'm always behind the the chat and everything. Let's just thin that. It's always easier if the cable is a bit longer. Then you can put it like in the third hand. Okay, that's good. Let's make it magic smoke proof. Go on there. Oh, these are even with glue. Interesting. Like some heat shrinks have glue. This one does have glue. And you can see it like squeezing out the glue a little bit on the side. Makes it water safe. Not like this is like a thing we need here. Okay. I think that was already it with soldering. Make sure to run this cable underneath here again. And let's run it on the backside of these stepper cables. Then under the camera cable. Cable management in V0 is not easy. Okay, so this is one. And then the other. You know what? Let's just do the following. We switch the bath thermistor and the hot end thermistor. Just have to remember that later, but I guess it will not work without. Like we can swap this one down, which gives us a little bit more reach with the top connector here. So let's remove that housing. We can just want to cut the cables as little as possible. Here we go. I can recycle that housing. And then we need to recrimp these. And these we cut way too long. Let's be generous and put it here. And then we do the same thing as before. We crimp two. 2 cables on 1 JST connector. These silicone wires are super simple to crimp. But that is too much bare wire I'm having here. Let me snip off the tip of this. Yeah, it was not good. Like here again, like it crimped the wings like in a very weird way. Like sometimes this happens with these crimping pliers. I don't know why. Yeah, now it crimped it nice. Ah, but the bottom cable slipped out. Well, it's on very well. Okay, that's accepted. No, it doesn't look good. Let's give this one more shot. A bit more. Now I jinxed it, I think. Saying like these cables are easy to crimp. Give me a second. This is not the most ergonomical working position here with these short cables. Okay, that's not really. It's not like the cable is again too long. Yeah, no, it's too long. Okay, give me a second. Like, let's leave that for a hot sec. Let me quickly do something else. Um, so if we want to have this back in here, we need to put the two Vagos here. I do not have. I don't have any VHP tape here, so we quickly need to get that. But besides that, like if we have VHP tape, we can put this one here. Here I do have VHP tape. Let's see, maybe we can just reuse this. Oh, it's a bit tricky now. So I think these we need to push all the way over because we need to have access to the USB port here at the back. How do we position this? I think this is the best we have. If we do it like this, we have like a tiny bit of space here, and here we have hopefully enough space for the USB cable. Oh, we don't. We 100% don't. It's a small printer. It's a very small printer. I mean, like this, it would work. Then we just need to figure out how to do the Wago connectors. Maybe then instead of like these, we use the through connection type. Or we do it like this, one left, one right. That also works. Let's do the one left, one right option. And I think like this, we can have everything in place. Okay. Then let me try the crimping of the impossible cable again. I do regret that I didn't accept the semi-perfect crimp. Because it was together, and I'm fairly certain it would have held up. I'm not quite sure what the problem here now is. Yeah, because they always like slide apart when I want to put it in a crimp. But if I remove more isolation, the wire part in front is way too long. And actually is already too long. Which might actually be part of the problem. Maybe try to like twist this together. Yeah, it's already a tad too long. So let me take off a tiny bit. If I do that, I will now really have to go for it. Okay. Yes, I think we have a crimp. Whew. That was not fun. This needs to be in the bottom position. Hope we get this in here. Perfect. Whew. Okay, well, we only have to do it one more time. Where is the other cable? Ah, here. For this one, let's actually just wrap that around the yellow one to keep them together a bit. Yeah, first attempt. Not sure what was the problem with what the problem was with the yellow one. That did not want to go in at all. Double check. Ground is on top. Yes. No. Doesn't go in. Yeah, no. Okay. Whew. Perfect. I always thought like I damaged the pins. That would be really awkward. Okay. Check. LEDs. We have LEDs. The most important part. Let me quickly jump and grab VHP tape. Then we can glue the Wago connectors and get this ready. I'm back in a second. Here we are, VHP tape. So let's just get two small bits. I'll just put this on the opposite sides. I think that's really the best layout chance we have. Yeah, perfect. And then we can still remove the plug. That will be a bit painful, but it should work. And we have enough wiggle room here for the USB. If we can, I would move it a tad. Yeah, but we really like already quite on the edge here. So I think this is the position we get. Would be like a right angle USB-C adapter would be very useful here. Now, do I feel confident that the VHB type I have on here will hold that in place? I think I'm not. Let's get rid of this and put like a fresh bit of VHB on here. Let's ignore this little tiny bit there. So we put generous bit on this side. And on this side. And this part, I think we should replace anyway, because we don't have a strain relief, which bothers me quite a bit. So I think we should take this part and basically fill that hole in the center here. And where that hole is, just like mount like a little like pole with a screw, where we then can have a strain relief for the cable. So for now, this is fine, but not like a long-term solution. Okay, let's unplug this. And let's see if I can slide this label down here. Otherwise, we kill the label. Okay, we kill the label. The label is killed. And now we can just like decide this one is ground. And this one's 24 volt. Then for our CAN bus cable, we use the same floppy silicone cable that we also used for the Pullman. Not sure if this is the best, but this is working quite well. So one cable has a marking. Let's make sure that we use this one for ground. And then I think the length is quite important. We need to figure out how long we will make this. And then I think actually maybe we should cut the ground side here a tiny bit shorter. Because then we can have a little bit more wiggle room here on this side. And to be honest, lengthwise, yeah, let's just copy the cable that was on here, right? So it would be something like this. And this cable then basically goes. You know what we could do? We could also just run it through this little hole here. This is which is meant for the Bowden tube. I think there's enough space here to run both, and then like the zip tie will just go around. Then this basically will be our cable strain relief. Okay, then for these two, let's just randomly decide what is where. The only problem is I have no clue which three or which of these terminals we need. Yeah, let me also quickly clean up here because I have like basically no space left. We don't need to solder anymore, I hope. I printed my first TPU part yesterday. I was super scared, but it was flawless with the default Voron profile. I definitely had too much respect. It's exactly the experience I had. It's exactly the experience I had. I printed also in December. First time TPU, and yeah, it worked fine. Like it's slow. I mean overhangs are not really a thing. But besides that, it worked quite well. It's really cool like material to have. I used it. I got one of like I have a old Bosch circular saw, and then they have these Bosch saw track. Um, they have these like tracks, and they're like stupidly expensive, as you can see. Um, and I got one very, very, very cheap. I mean, this is like 2 meters, so that's why it's quite expensive. But yeah, they run like around 100 euros. And they have these like you see this blue lip here on the side, and it's like a rubber material, and it's basically preventing the wood from like getting damaged from by the saw blade. When a saw blade exits, that rubber basically holds or supports the material. But because my saw is relatively old, it doesn't fit on these tracks. So I 3D printed the adapter, which worked amazing. But then this like lip was way too short. So I actually 3D printed. Here you can see it like close up, like this blue lip, and I 3D printed that with TPU. And then you just it's like way too long basically. And then you just use the saw to cut once, and then like the lip is exactly where the blade of the saw is, and it worked amazingly well with the TPU. That was my first CPU print. Wait, we wanted Pfizer Yukon. Mm, do we have a pinout? It's schematic. Is that what we want? I need a bit more than a picture. Here's a picture from. I don't want anything. Okay, this is a very weird, ugly picture, but it works. So if you flip it over, so Kanhai is in the center. That's pretty much all we need. Kanhai is center. Let's start with that. So I'll just put it in here. So Kanhai is center. So if we use this to like align it with my how I see the picture on the screen, then low is on top. Okay, so these two we need to connect. Like which one goes where, we don't care yet. For us, it's just a cable. And then we can connect that. Sanity check, so I would flip this board, I would flip it like this. And then can low is this one, can high is the center. Okay, so this one, let's put the plug on the other end. And then we need to support that. Oh, before we put the plug on, let's actually support it first. So what I did on the poor man, and that worked out really, really well, I used this solid core wire here. And I just basically did the following. I wrapped it around on the bottom, and then I just basically like intertwined the two a bit like this. Now we wrap it around once here at the end. So this is what I did on the V0. And then, and on the V0 on the poor man. And then we just use some, oh god, this will be a mess. Which one of the two do we want to use? Let's see, this one is a bit smaller. So this is just like normal cable sleeving. Just need to get it started. Let's see if we need to put some tape on the tip or if we can convince it. Yeah, I think this is a bit too small, this one. Let me quickly cut this. And then just melt the tip. And if you melt the tip, like it stays a bit more together. Really hope BTT takes over the Eddy contact and streamlines it. Tap plus Eddy seems like such a good combo. Yeah, definitely. Like for me, like I really want to have like the automatic Z offset. That's kind of like the holy grail for me. Quickly use. It's like super random. This is the tape I have available right now. Let's just put a bit of tape around the tip here. See if this helps. Oh, maybe did melt it a bit too good. I think we need to use the bigger. Oh, now it works. Oop, okay, I think now we are in business. Just a bit of like, yeah, it's clicky, and the auto Z is so nice. Just would like to get rid of the slow mesh. Yeah, that's the thing. I mean, if you have both in one, that's definitely the best. See? Yeah, I think we are good now here lengthwise. Now we just need to figure out where the cable starts. Think around here. Yes, I just hit that. Perfect. Okay. Yeah, I'll just throw it on the floor and deal with it later. Perfect. Now we have like a very nice cable here. It's quite stiff, but the silicone cable is very flexible, so it will not be damaged by the repeated movement. And then the solid core around it just gives it like the stiffness we need. Works. Okay, let's start by just crimping the connector. Let's just use what they gave us. Which is... Are these all the same? These are JST. These are microfit. No, these are JC. I can never get that straight. This is JC. This is microfit. I can never get that straight. Okay, that's number one. Additional solutions that will be released Eddy Touch. This is a feature that is currently being implemented that will allow Eddy to sense the point at which the nozzle touches the bed. Yeah, exactly. That's what we want. Yep. So maybe one day. I'm pretty sure it's coming and it's coming rather sooner than later, I would assume. Like I have quite high trust with Big Tree Tech when it comes to stuff like that. I feel like they really try to support and improve their products. Oh, not fully crimped. Okay. 2 more to go. Also, when clicking at the moment, it's really consistent. That's for sure. Yeah, that's the big benefit. It's just like, yeah, if it's faster, I mean, it would be perfect. I run the on the switch wire. I run the inductive probe. And yeah, like if you print a larger part and it takes like a 5x5 mesh or something, like it really takes its sweet time. Okay. Yeah, I feel like I have to use the smaller crimping setting on these cables. Weird. Last one. Mine is some problem, but I know the cause. I got faulty Z spindles and they grind up the nuts. Oh shit, yeah. That's the same actually I had on this machine here. Exactly the same. Like the POM nut on this machine was constantly eaten up by the lead screw. LDO already sent me a replacement. Yeah, that's exactly exactly my experience. Seems like that happened again. But I'm all too lazy to swap the motors for now. Yeah, that's exactly what I had on this machine. Exactly the same, Jonas. The lead screw was like ever so slightly oversized, and that caused the palm nut to be eaten up over time, and then like you got a lot of slop in that. That's exactly one-to-one what I had too. And then yeah, it's like quite a pain to replace the Z motor. Like also on the V0, like you have to take a lot apart a lot to get to that. The good thing is like Jonas, what I can tell you, like since I replaced that, I mean you have a different machine most likely and everything, but like I have no issue whatsoever now with the Z motor. Guess Thomas is pressing incorrect. Yeah. Yes, but here's the thing, right? Like if you have a brass nut, it's not eating the pom or like the nut as quickly, but you also will have binding and other issues if the diameter of the lead screw doesn't really fit. Yes, let's quickly check the pin out of this little guy here. There's after open. Yes. So let's see. So I think I'm just wondering like which orientation that plug is. I think the CAN wires are on the front and the power and ground are on the back, basically from this perspective. Also, before we do this now, let's quickly like let's first crimp it and then like we have to pull the cable through there. So this is the ground cable. This one is the ground. The other we need to quickly measure. That would mean that this goes here. Let's verify that quickly by measuring just. We'll save some work if we don't have to do it again. So we're just quickly checking which one of these 4 pins is ground. I think it's this one. Ground. It's none of them. Okay. Let me quickly check. Which one should be ground? It should be the last one of these. Yeah, I was right. I was right. So then you are ground and you need to be here. You need to be here. Then 24 volt is next to it. It's yellow on white. I don't know why people do that. Which we should be able to quickly determine here. I'll quickly remove that cable and just jam a probe in here. One of them. Oh, the probe did not want to stay in there. This one is 24 volt. Okay. Then let's quickly check our UCAN thingy again. So CAN high is in the center. And CAN high is over the 24-volt cable. So I'm connecting, which one is it? So this is CAN high, which should go here. Check. Yeah, this is the ground is on this side. So CAN high goes here. And then last but not least, CAN low is here. Um, where there's a lot of stuff going on. Great to hear. I had these black lead screws that were coated. The new ones are steel. Yeah, I still have the coated one actually. Like they replaced the coated one, the Teflon coated one, with another Teflon coated one for me. And I mean, I don't know what machine you have and stuff, but like for that, there was one faulty batch of the V0.2 kits, like the first batch basically. And there the motors had like the Teflon coating was slightly too thick, causing the issue with the POM nut. So I'm not quite sure which machine you have, but yeah, if they switched with steel, the problem is also gone. Then you just have to lubricate it most likely. But yeah, shouldn't really be an issue. Okay, let's make sure to push the sleeve all the way to the end. And I'll also use the lighter a bit to like melt the sleeve again. And you can just kind of push it together a bit. And then we'll use zip tie just to hold it. If we would have been fancy, we could have added like a bit of heat shrink over the last bit. That's be fancy. Let's quickly undo this. Let's quickly undo this and we just let's see, can I somehow mark one of these two cables? So the one that I fold back is in the middle. Okay. Heat shrink. Let's just take a short piece of heat shrink. I'm not gonna heat shrink it yet in case the cable doesn't work and we have to repin something. Just that it's on here. I hope this goes over everything. Oh, no, this is not big enough. We need bigger heat shrink. This one. Um, in terms of acceleration, that's another thing I need to investigate at some point. I have the valley-like thing with 2 spikes, but the speed I use, I do not see what usually, if you have two spikes, that usually means like there's a loose screw or something. That is usually what two spikes mean. There is the resonance holder or like the frequency holder macro. Like if you look online for like clipper frequency holder or something like that, you will find that. And the benefit of that is you can basically looking at the graph you get, right? You see where the second spike is that you don't want. And then you can use the frequency holder to hold that exact frequency. And what that allows you to do is you can just trigger this exact frequency where you have the second spike. And then you can just like put your ear close to the printer. You will hear the resonance frequency. And then you can just check like where that comes from. And you can like, for example, put your finger on a certain spot on the printer. And like if you dampen that a lot, then you know that this is the spot where it's loose, basically. So you can like chase it using this resonance frequency holder. But here's the thing, like if you get, it really depends. Like if you get like EI shaper or like MZV shaper, like it's fine. Like, I mean, you can of course always improve the accelerations, but yeah, I'm not super into that. Yes, I need to measure again because like I undid the thing. Depends on what causing the non-main spike. For Y, I would guess 99% of the time the Bowden umbilical and will not affect prints that much. Yeah, like for me, the last stream we also had like a lot of issues with Y on this machine. And for me, there was just like the screws on the motor mount were loose. So it's like super unrelated to the actual movement system. The problem is just like any loose screw will just like induce a like it will change the resonance frequency in a certain sense. And even if it doesn't have like a direct print influence, like Clipper can't measure the frequency properly. So this one should be can low. Yes, so this is can. Let me double check. I want to see the ground wire. Yes, this is can low. Let me check the UCAN again. Can low is on the outside. I was actually working on the poor man's Core XY quite a bit like last weekend. Also like chasing down issues with the shaper, although like the shaper issues on the poor man were quite severe. But I can report that I fixed pretty much all of the shaper issues on the poor man Core XY. Like it has really good shaper now. In fact, I mean the Y graph looks weird. Like it looks a bit weird. There's something still going on I didn't figure out. But even with the weird Y shaper, the recommendation for Y was like 12K acceleration, and for X it's 14K acceleration, and the X graph looks amazing. So on the poor man Core XY, we are getting places now, and I didn't do like a lot like big changes. I was just like minor tweaking basically. Mm, I would reach after doing some planned reworks and see if it's gone. Yeah, like taking stuff apart and putting it back together sometimes fixes random issues like that. I remember that first test I forgot to close the SB filament switch, and that graph looked funny. Yeah, exactly, like small things like that. There's also like a discussion sometimes whether you should print with a filament spool on or not. Because in real print, obviously, like you will have a spool on the spool holder. I really hope this cable is long enough. Okay, so technically we are kind of like in a state where we could like mount this, right? The only thing we need is like this like cable tie here to hold it together. So let me just quickly fiddle that in. Let's see if we manage. Let's actually put it from the bottom that we have the end of the zip tie hidden. Just put this over here. Wait, if I do it this way, I need to go around here. Ah, shit. Let me quickly, I didn't want to pinch this cable here. I just gave up at some point. I may have messed up the X mounts a bit while building. I already have reprinting of those on the list. Once I swap the new Z motors just to make sure. Yeah, I think that's a good plan. What axle do you get on your 250? Not sure what the norm is on stock entry. I think the default in config is 4K. I use 5K. Sounds okay. Like that's also around what I use on the switch wire. I see, then I should stop worrying about it and just send it. Well, you can always improve. Oh wait, this should go on top. Now let's see if we can convince this to fit in this spot. I think it looks good. There's just one massive issue. We have it backwards. Shit. The screw holes on the line. The screw holes on the line. This was supposed to be on the back and not in the front. But the problem is, if we now do that, whew, I'm also not sure if the cable is long enough. Oh, it is. Yeah, it is. Yeah, it's perfect length. Perfect length. But I think this is good. So the only problem is that the screw holes don't align. Let's see about that. We lost the nozzle. Two. My spare Raven nozzles came out. Okay, just to trying to show you the problem. So these screw holes here don't align. If I So they're basically like, this is not center. Um, I'm, yeah, I'm not sure why we have a random JST plug here. So technically we can just flip it. Let's just try to flip it. So it's just a bit of tape. Right? So it's, let me just quickly check that I'm having it now correct. Yeah. So this would be now like this. Let's undo that quickly. Now it would be, oh no, wait, there's the USB plug. We cannot do that. Yeah, no, this is a bit too short. Let's just put the Vago a bit more to the front. So this bit more to the front. Just wiggling around with the position. Here we go. And then we can squeeze it all in here. I would be much, my X would be much better than my than the 5K. It was the graph with one spike and recommended 10K. Well, if it reaches this one thing, then you just need to spend time to figure it out. That's the unfortunate truth. Is with these acceleration issues, like you really just have to sit down and like try. There's no other way to fix that. It's just spending time. I think the vibration we're still overall a bit higher than you want. I have the LDO box turtle thing coming, by the way, Chris. If I should test something for Octo app, once it's here, let me know. Well, you're always happy to test it. I think it should work because it's just multiple extruders, I think. I mean, I'm also having a multi-extruder machine coming in basically this year. um, that's the big project this year. Don't want to spoil too much, but that is in the works. But yeah, if you want to test, just test. Let me know how it goes. Always happy if people try stuff. Uh, Woo! It is in. But I have bad news. I think now it touches the belts. Can't have it touching the belts though. Oh, there's the screw. Oh, that's from the. I was like, where does the screw come from? It's from here. Yeah, we need to do it the other way around. So now the zip tie basically pushes the stuff backward, which we can't have. We need to make sure it's pushing forward. Every time I turn it, there's like more random filament bits out. So this setup of the zip tie is no bueno. Also, a kink in my. So we need to push it forward, which means we need to go through here. Oop, you don't see anything. Yeah, X is twice Y, but that should be normal at least. Yeah, I think so. Unless you're on a switch wire, as I learned. On switch wire, Y always has a um, higher acceleration than X. I don't understand fully why, but it seemingly is normal. Yeah. Yeah. Now it clears the belts. Just like we want. Okay, let's fix it in place. Oh, the screws are now too long. Because before it went through the board, but now it doesn't go through the board anymore, of course, because you removed that board. Let's quickly check our little magic box for M3 by 8 screws. That should be like good. Yeah, M3 by 8 is good. Perfect. Oh, there's. Yeah. Ugh. Now it's perfect. This cable is quite short here now, but yeah, it is what it is. I think we could have pushed the canvas cable a bit in. Let's see how it behaves on the other side. I think cable-wise, we are actually, in fact, done. I think that's it, right? Like we rewired LD, we rewired the pipe power. Let's just do like a very brief sanity check for the pipe power. Oh, the USB cable, of course. I just always like to quickly do like a sanity check if there's a short and if the ground is properly connected. So ground is connected, no short, and this one is not connected to 24. but to the 5 here from the laser. So that's fine. Let me quadruple check. That is actually 5 volt. SKR Pico. This is 5 volt. So we are not killing our Pi by turning this on. And then I think we are ready for magic smoke moments. Mainsail has some special UI for toolheads. Is saying not sure how much Octop has or needs that. There's, you mean for the multi-tool? There's special UI in terms. What special UI would there be? I don't think there's a lot of special UI for that. You can select the extruder for extruding material. That's pretty much it, I think. Might miss something. But yeah, with the, I mean, most is just macros, right? That you unload and load filament on the right toolhead and stuff like that. Oh, we forgot one cable. Let me. This should also go under the Boden. Oh yeah, like I personally never had the multi-material unit, so I basically listened to people who have one, and they told me what they need, and that's what I built. Although most people that have multi-material have a Prusa MMU, and they run Octoprint, Octoprint with OctoApp, and then they have the MMU3 plugin. And for that, I have some special UI. Like it's mostly like the filament management that then has special UIs. So if you use Spoolman with like the box turtle with Spoolman, then you will have like some special UI. Cool, yeah, but it is pretty much all we need, right? Not missing anything. It actually looks a bit cleaner, I think. I feel like it looks a bit cleaner. Let's turn it on. Oh, it's like, where's the power cable? Okay, ready? We do not have the toolhead yet connected. Let's connect the toolhead. Let's actually do it all. Oop, that was the cable. Let's do it all in one. By the way, random question, maybe someone knows. Is it normal that I need to tune the infill wall overlap? I use Orca and crosshatch right now. I never had to tune that. There's one setting in Orca that you might not know exists, which is the, I don't know how it's called, but basically it sets that the infill is only done on every second layer. That might be something that causes a bit of issues sometimes. Besides that, I've never had to tune anything related to infill, really. Yeah, I'm struggling now a bit to get it on because of these like new connection points. Okay, it is on. Let's see if we can. Bit painful now, but it's on. Let's also add 3x8. Here, 3x8. Let's use, let's connect it to new screws we can put there. I mean, you know, maybe it helps. Maybe these two help to make everything a bit more stable. I don't know. I never had to. And then we need to have the two big ones from the front, and everything is mounted up. Check. And now the only thing we need to do, we still didn't do the heat shrink here, but let's first make sure everything works. So this is then connected, and then we also have to add like one zip tie here. And I feel like my bone tube is like a tiny bit short. And then maybe we can also like add a bit of connection between the bone tube and the wire now. But this looks good lengthwise. I think lengthwise we did a good job. Then the moment of truth. Never tuned the anchor length on my profile is 40% and max length is 20. Never touched those though. No, I also like I never even considered tuning that. Okay. We tested everything. Off we go. No magic smoke. Which is good. Man, like there's so much dirt here, like bits of filament and it's like always like when you turn over a printer, like so much gunk falls out. It's crazy. I actually use we'll use a vacuum cleaner later and just like clean everything out. Okay, but I think then there's nothing we need to do here anymore. Let's just flip it on its feet. And look at this. I think I know I copied Ali's profiles back in the day, and I think it used some tricks for faster infill, normal straight lines. So I tuned off the gap time. Okay. Well, sometimes it's actually good. It's like one thing I did at some point for the switch wire is like just, you know, start with a new profile, just with a standard profile, and start over. So it's like, yeah, sometimes you just change random stuff and you just forget, and then it just lingers in there and causes problems sometimes. Like this loose panel clip here. Okay. Then we have to fix a lot of configuration related things, I think. Let me see what Clipper says. Clipper says not happy. That one is for sure. Unable to connect umbilical. Yes, but I think we also have to still continue No, we flashed everything here. So let's go to configuration, printer config, and just quickly check for devices, and then for it doesn't say CAN here, which it has CAN selected. Oh, and you don't see what I'm doing. Many problems. Here we go. We have a CAN device, which is our Toolhead board, which is amazing. So let's check here. So the MCU EBB. This one, can you help me? Sample config. Sample config. Here. So we have this canvas UUID. Let's just copy it over. Before I change anything now, don't save. Let me just download the thing just as backup. You never know. Then MCU umbilical we remove and we say canvas ID. And then we grab this beautiful canvas ID we have here to put us here. And the Raspberry Pi is still an MCU. So, um, well, let's just first go through and search for umbilical. Toolhead light. Now you should remember where we put the toolhead light. Let me investigate. The toolhead light is on the RGB port. So here we go. So this is on PD3. PD3. So it's EBV PD3. Then next umbilical. End stop pin we don't have. Extruder. Extruder is now important. Let me actually maybe close things we don't need anymore. This we are done. This we are done. This we need. This we are done. Pico we are done. Oh, we are not done with the Pico. We need to keep this open. Oh, let's close this one. Keep this one open. And this one we are done. Okay. So then extruder is PD0. Extruder. Oh wait, this is extruder. Why does this look so different? What am I missing here? So this is just a heater. But this is not the stepper. What am I missing here? Heater? Heater? Ah, here. Yeah. This is now where we want to copy our stuff. Extruder here. So the step pin is EBP PD0. Then the direction pin is not PD1. And the enable pin is PD2. But is it inverted or is it not? Yes, it's inverted. Then the microsteps and everything, let's just keep that as is because that is for our extruder setup. I don't think the heater pin we need to set. And this is now where this like weird second section down here is. We can just kill this. Um, so the heater pin we need is PD13, EVB PD13. The sensor type is this one. Oh no, the sensor type we need to keep because this is specific for my hot end. This is not the Toolhead board, that's the hot end. The sensor pin we need, and the sensor pin is PA3. Okay. And then this should be it. Yeah. Then umbilical continue. Then we have the part cooling fan. We now need to check which fan is which. That's might be a bit random now. I mean, we could also check the pin out. The one with 2 crimped on is in the center position, which is PA0. So PA0 is the part cooling fan. EVB PA0. And then the hot end fan is, the other one is PA1. Then NeoPixels. NeoPixels now changed. Firstly, we don't have 2 anymore, we only have 1, because we kind of like drive them now like in parallel. Yeah, it's whatever. We call them RGB. And then these are now on the SKR on the thermistor. And we also need to switch the thermistor, so that's on GPIO 26. GPIO 26. A beeper, rest in peace. We don't have a beeper anymore. Then the bad thermistor, we said we need to switch. Heater bed is not GPIO 21 anymore. 27 it should be, but not the sensor pin is 27, GPIO 27. Check. Do we have any more umbilical references? Yes. Temperature sensor chamber temp. Do we have something like that? I don't think so. This one we need to copy. Okay, chamber temp is also, it died. Then let's quickly do the ADXL, which is up here. EBB. Do we have any more umbilical references? Temperature sensor umbilical temp. Also, this one is not a thing anymore. But we can rename that to EBB. And that's it. That's the end of the config. Save and restart. Oh, by the way, we can do the heat shrink now. Shall we quickly do that? Can I? Technically, I should be able to unplug that. Let's see. So then we have this. We can also put the zip tie here. And that completes the hardware setup. So restart method is not valid. Then let's just remove that. MCU protocol error. Okay. Yeah, this is the problem most likely. So basically we have now mixed Clipper versions. So we have 11, 12, 11. Ay, 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 ay. Yeah, I know. I know, Ravekeeper. Let's let's update. I thought we would be done. But why didn't Flash 12? But it's yeah. So I think these are fine. It's really like the EBB that is not a problem. But why did it flash a newer Clipper version on that? Because preferably I would just flash the old one on that, to be honest. Nah, okay. Oh, yes, 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 yes. I understand it will be painful. Updates are always fun. Just pray there's no conflicts. Yes. If it would start, I do my best. Oh, I think I killed it. Oops. It's like loading the page. What happened? What did I do? I think I killed it. It's also not connecting via SSH. It saw the updates and was like, yeah, nope, nope, nope. Um, to be honest, let's wait like a minute and then just kill power. I have no clue what now happened. Yeah, here we go. SSH still doesn't connect. Oh, now it connects. Okay, something was busy. But it doesn't know update? Let's do it one by one. Yeah, let's start with Crow's Nest. That was funny, like it doesn't do it. System is up to date. Here, screen. Something is up to date. Invalid. Hard recovery. I have no clue what. Oh, you don't see it. Like Clipper is in an invalid state. Because you remember, Jonas, that I said resonance holder? Yeah, this is exactly that. So I added that, and now it's not happy. Um, oh, now it's doing stuff. Okay, I have no clue what the holdup was there. Let's see what it does. Yes, we ran the OS updates. We did update up get update up get upgrade. So that's why the OS is up to date. The good thing is we only have to basically flash one board now because the umbilical board is out. So this one we don't have to flash. I mean, it's a really nice board. Like, don't get me wrong about that. It's a really nice board. I really like the LDO stuff. Like, it always looks really nice. I mean, it's the most expensive kit, but like, just like from how it looks and they really pay attention to detail, it's nice. There's no arguing about that. It's like nice touches, for example, like here, it's just a pin out. It's like written on the board being black. Yeah, I'm a fan of that. So that's all nice. I'm curious what I can do with this board in the future. Like, I mean, it has quite a bit of pins, so let's see if I can find a use for that. You can always use it as a clipper expander, basically. The red paint on terminals is so handy. Yeah, it's also like, it's like small touches. Like, like the cheaper boards, they just don't have that. It's like very simple. It's like costs nothing, but yeah. Shame we don't need that board at the moment anymore. Yeah, but honestly, I feel no difference. I don't think like these extra screws in the back do anything. And it's also just connecting to the printed part. I'm really curious if I can have a difference using the CNC machine part here for the toolhead mount. Because this is like most of this flex, like some of it comes from the rail, of course, but some also comes from the printed part. Recovering clipper. That sounds amazing. So I guess my resonance holder is gone after that. You have a lightweight beam. There two now as well. Yeah, it was like we did it before Christmas. I was moving to the new place in November, December, basically. And then in the beginning, before like I moved my stuff, like I did some like low-key streams basically, and like this X-axis beam was one of them. Also, like here we now have CNC machined XY joints. Like these are not printed, these are CNC machined. So I got the CNC parts, like the XY joint here and the toolhead mount. They're like CNC machined because I can. Like we noticed that here one of the XY joints had a crack, and when I removed it, like the other one was also like quite flimsy. So I think the printed parts there were really bad because I printed them like open air basically on my Ender 3 back then. And then also like again like 1,000 hours, and like these parts here are really thin, like vertically, and they're like stacked vertically, so it's like a very weak part. But yeah, like now they are replaced with the CNC mount, and then basically I have the most important parts as CNC. And like it's a really like I showed it in the beginning of the stream, but this is like what it prints at the moment. It's like really nice quality. Like there's if it would focus, it would be even nicer. Really doesn't want to focus on that. But yeah, it's like really nice quality. Like you don't see any layers basically. Like it's really, it's only here these VFAs basically on this like one side. But yeah, that's VFAs is VFAs. But yeah, it's like really nice quality. Like I'm really happy with this machine. Hi there, Sven. Good evening. Yes, feel better. I have no clue what got me. Like, in my company, like everyone was sick the last 2 weeks. Like, it was like absolute plague. I was just like, yeah, headache, tired, sore throat, coughing, runny nose, like all the good stuff. It wasn't too bad, but sitting here for like 3 hours talking is not really the most helpful thing when you try to recover. But yeah, I survived. God, I wish we had the brand screen here. So nice. Yeah, like actually, like it looks a bit like the red brick green. Um, but it's a really nice filament. It's I ordered this week. I mean, this is the black. It's Nobufill, ABS-X. Very nice material. Like it prints like a dream. Like really. The only thing I noticed, like I usually for ABS I use Form Futura so far, and the Form Futura Titan X is their ABS brand. I can basically grab it from the build plate right away, and I won't have any deforming if it cools down quickly. With this one, I noticed I have to leave it on in the printer for a little bit longer before I take it out because like flat parts otherwise tend to start to deform a bit. But besides, like it really prints like a dream. Like this is really nice. Like it's really nice material. Yeah, this is Jonas. This is a wristwatch extruder. There will be more of this coming soon. Speaking of multi-material. Yeah, those are the parts I think I did not treat well on assembly on my Trident. Also, thought about getting CNC ones. But I think we'll stick to the printed ones for the Trident, maybe if I get a V0. Yeah, I think for the Trident, like they are a lot bigger, so I think they can like handle a lot more beating. For the V0, they're just like very like small and fine. So I think here it makes more sense. Ravenkeeper, I know, is CNC machining XY joints for his Trident. That is on his list. Um, so yeah, that's like I think the CNC machine parts are nice, but it's not really needed. Like the print parts are fine. Let's see. I think this is now just that. it is. I mean, it's doing stuff. How much RAM do I have here actually? How much RAM do I have here? What does it say? I think 4 GB. Yeah, it's 4 GB Pi. Wanted factor is bigger than needed factor for sure. Yeah, I can subscribe to that. If I ever get my own CNC, I will do CNC parts for sure. I think it's like not as easy to manufacture them. That's what I learned. But for sure, it's like it's quite a flex if you CNC machine your own your own printer parts. But yeah, while we were waiting, uh, this is the latest Banshee of my poor man's Core XY. I mean, never mind that the MCU crapped out and like it didn't complete, but this looks pretty good. Um, I mean, there are some artifacts in the hull. Like it's a bit hard. Like this material really sucks to show on camera, but mm, you see here, there's like a bit of like layer consistency still. But overall, like this is like quite a usable Banshee. And yeah, again, like this comes from the poor man's Core XY. And it's printing as fast as this V0. So this is actually really good. Like the bridges and all like is nice. You have very good detail here. The only thing I need to like figure out still is like a little bit of the Z inconsistency. But overall, this is like a really nice Banshee. So yeah, that's also still happening. I did not give up on that machine. It's really like small tweaks now that I do. Like I just printed it and actually printed some production parts. I don't have anything here yet, but like they all turned out okay. So I can use this as a printer now. Um, I always use Novofill filaments ABS. It prints great. Here it is. I actually ordered from Novofill this week, and they gave me this spool for free with that's their new spool design. Um, which is like the new spool is like way nicer than their older spool. Wristwatch, yes, but not the G2. This is the there are two wristwatch versions. This one is the normal BMG internals. Uh, I just wanted to test out the filament basically. And I had BMG internals lying around, so I printed the wristwatch. Is that issue on extruder shoes? Dual gear can be tricky. Currently printing parts to try out single gear clockwork 2 with bearing plus gear to see if that does anything. That is an option, but um, if I do this, like this is another test part I did, and it's just like single walled cylinder. Oh, wait, let me see if I can reload this by now. Single wall cylinder, and also here you see a bit of a pattern. I mean, it's really hard to show on camera, but like it has a bit of wood grain going on. So it might be extruder related. Yeah, from here you see it a bit, right? Like there's a little bit of like a pattern. So it might be extruder related. I'm not 100% sure. But on the Banshee, it looks a bit Z related because it's like really like one layer here on the bow, basically always going through. Might be both. Like I know that my Z might be a bit iffy with the belts. It's something I need to figure out. Okay, I think we are, in fact, almost there. Well, Clipper it didn't do. The one thing we needed, it didn't do. um, Maybe we have to do this manually. Yeah, Woodgrain is BMG curse as far as I heard. Yeah, it's not uncommon, but I'm thinking, what BMG gears do I have in there? And I think I have the super cheap Ali BMG gears in there, which might be cause part of the problem. But maybe that we can throw this little fellow on there, which also has BMG, but it has the POM BMG gears, which are a lot better. Reinstall complete. Then let's update Clipper. Okay. Then I think we already have the documentation here. Mm, flashing firmware. Let's just use this here for flashing firmware to get the settings. Okay, we now are up to date with Clipper. Yeah, now the resonance holder is no longer a thing. Like we killed that. I need to try some proper ABS like the Novo Fill. I ordered too much eSun ABS Plus in the early days. I'm still trying to get rid of it. They ordered a lot. But I think for certain things, a proper ABS can be better. Like, I mean, what's a proper ABS? It's yeah, I never tried the eSun, but like I think it works. Like quite a lot of people use it. Um, so yeah, I think it's fine. Like, what I like the ABS I can recommend is I mean this is the Novofill ABS-X. I don't have a lot of it. Like this is basically 50% of what I ever printed with the Novofill. I just ordered my first batch last week. And it's really nice. The other one I can recommend, which also prints very easy, is the it's a Novofill. It's very nice. ABS-X. They have like quite nice colors as well. Actually, I ordered the reason why I ordered at Novofill is I wanted one specific one, which is this one. This one is what I wanted. It's marble white, so it has like little black specks in it. So I'm really curious. I hope it will turn out great, but this is the one I really wanted. That's why I ordered like a couple. Um, what I also can recommend is Redline. They are quite good. Redline filament are quite nice. I don't like the ASA they have as much. The ASA is a bit iffy to print for me. I don't know why the ASA is. It's here behind the chat. Like this one is a bit iffy to print. But ABS prints very nice. And they also have really cool colors. I have the Apfelgrün here. This one is this. It's like a little like it's not as like neon as the Novofill. Yeah, this is the Apfelgrün. And I also had the dark green. I tried a couple of greens, as you can tell. The Dunkelgrün is also quite nice. So this one I can also recommend. Um, And then like my go-to for black, most ABS I print is black. Um, is this one. This is by far what I print the most. It's the Form Art Titan. Um, I order, I think I'm like around 10 spools of that stuff by now. Prints very easy, prints really easy. And compared to the, like, for example, the Polymaker ABS, on the Poor Man's Corksy, I have this turquoise, which is the Polymaker ABS, and I have the black, which is the Titan, the R Titan ABS. And I really feel a difference in terms of layer adhesion between the Form and the Polymaker. It might be print settings, but I feel like I print the Polymaker quite hot already. Would need to check temperature, but I know I got like cooling issues. And still, like the Form has like way better layer adhesion. I don't have like a direct comparison with the Novofill or something, but like because I had like the same parts printed from the Polymaker and the Form um, I really have like good comparison there. And this one is extremely strong. That's my feeling. Um, the Polymaker ABS I don't like too much, to be honest. I know it's very popular, but like for me it doesn't print super nice, and I always had issues with overhangs. So that's my ABS recommendation side story. um, if you have a 693ZZ bearing laying around, it could be worth testing a single gear and see. I might have one of these flying around. I have quite a lot of bearings. I never had real problems, but whenever I have a part fail, I wonder if a good ABS would perform much better. Yeah, that's the thing, right? Like, as I just mentioned, like, I do feel that there are differences. I mean, it's just my very objective opinion and observation. But for example, like, between the Form and the Polymaker, I do feel that the Form is a lot more durable. And it also prints super easy. Like the overhangs are no problem. Like also with the Novofill, like here's quite a bit of like overhangs. Like this is a perfect overhang. There's like this printed basically flat like this. So these are all overhangs and it prints like a dream. And they have glitter. Link for the last one. The last one is Form Futura R Titan is this one. You can order it directly at their, like I always order directly at the like at the company. Like with all filaments, I try to order directly. And then they have two. They have the R Titan, which is like the recycled one, and they have the normal one. But the normal one is quite pricey. So it's the R Titan, and then it's Titan X is the normal one. It's technically the same. They have a couple more colors. They don't have a lot of colors for that. That's the one thing. Like if you want like fancy colors, this is not the material. That's why I always use the black. But then you see here the normal one. It's only 750 grams on a spool. I mean, you don't see it, but trust me, it's 750 grams and it's like quite expensive. And this is without tax. So that is without tax, I think. So this one is relatively pricey, I think. But I'm not quite sure. Like, I think there was a toggle somewhere to turn tax on and off. I'm pretty sure this is without tax. So this one is more expensive, but then the R Titan is actually quite price competitive. It's the same, like they're all like around 30 euros per spool, like per kilogram, basically. I'll just drop it here. Oh, before that, sorry, now what's going on? Red line. Red line filament. I don't have like tons of experience with that one. Like from what I printed, very nice. And they have also like quite cool colors. And a lot of colors. 37. Again, like the Ace AX, I didn't like so much. I had only a sample of the Ace AX, and I was like, yeah, it didn't print nice for me. Like it warped quite a bit. Okay, let's go back. PD3. I think we need to put this all uppercase. Oh, but by the way, our Clipper issue is solved. I think like Clipper is always backward compatible, but not like forward compatible. So now all our boards are with random Clipper versions, but they're all like older. RGB1, exactly. So now we need to check. Oh, that might be in the macros. Yeah, see here we set RGB, so we only have one RGB now. So we can always kill the RGB2. Save and restart. Now we're getting somewhere. Yeah, just like checking. So basically we have now Clipper 11, Clipper 12, Clipper 11. It's like a bit of everything. Let's quickly check to get everything running. And then I think we can, depending on if you have time, update all the clippers. I got one more roll of eSun plus one Bamboo Lab ABS I got on sale. I want to try and then finally can try new ABS. How's the Bamboo Lab? Like I don't want to support them, so I won't buy it. But how is the printing? Let's quickly see. How do we start? Let's check the temperature first. So the bed is 26 degrees, so that is correct-ish, I guess. And the MCU temp is reporting, and the extruder temp is also reporting. So let's start with the bed. Let's do the full shebang. Let's just put to 30, quickly see that the temperature rises here. Yes, it is rising, so this is good. Sorry, let me do this like this for now. Then you see everything I see. So that is good. Let's try the hot end. Yeah, it's also rising. So that's good. So the temperatures are working. Then the Toolhead light is, let's try RGB. Uh-oh. This is a definitely no. We don't have RGB working. There's nothing happening here. There's a bit of green here, but this might just be like a bit of random, like see it here. Um, Bad light. I don't know what. Oh, this is the one in front. This works. Underglow, I mean, we didn't touch, so I would be surprised. This works. The underglow works. Um, the tool headlight works, but it's inversed. So we need to. Not sure if you can see that. See here on the corner, like it's inversed. So that's something we can fix quickly. Tool headlight. So this is pin not. And then I'll get us back to proper size again. So this should be fine. Tool headlight. Yeah, so tool headlight works. So we need to check the RGB. Like this one is the only thing that does not work. RGB doesn't work. Okay, but that would be, yeah, acceptable loss for now. Let's see. So we have the yellow cable here. Just quickly check that we have the pin out correct. Yeah, ground on top. And IO 26 on the bottom. Let's quickly check that we have it correctly configured. RGB. Oh, where is this? We have the backlight, we have underglow. RGB. GPIO 26. I think this should be correct. GPIO 26. Maybe that doesn't work. But I thought like you can use any random GPIO pin as a I've not tried the Bamboo Lab there, all black ABS, so I used one after that. So all black. But I will let you know once I get it. Yeah, let me know. Yeah, like for filament, I also try to like stick with local suppliers. Like Form Futura is like quite close to me. So I can order there and I have like next day delivery, which is quite great. Novofil takes a second to arrive because from Austria. And the Redline also from Germany takes a second to come over here. I don't know why this doesn't work. It should work. I don't see why it would not work. It might be something fancy going on with that GPIO pin. Because it's meant for thermistor. Yeah, let's see. I can live without it for now. Let's just see if it prints. Let's close this up. And then I can live without bed lights for a week. I think it was quite a quick canvas conversion, all right. Like I mean the when we did the switch wire, I think like it took like quite some time. Yep. Why does this not? And I will print the panel clips for next week. I can do like a fun hardware upgrade session. What? Fun hardware upgrade session next week, I wanted to say. Nope. Here we go. And we have one screw left, which is always a good sign. Okay. Let me just already preheat the bed. So that always takes longest. Let's not print black. Black is stupid on stream. By the way, I'm quite proud of this. Let me. Oh, can I mean, I'm not proud of the Chaos Thunder. Here, this is my printer closet now with most of the filament I have. And then here is all the boxes, like all the boxes here also go up there. And then my tools end up there. And then this is my hobby printer cabinet. And like these are like there are like random filament holders I made. And then the honeycomb wall basically closes against that. And that's like most of the tools and stuff I have. And I'm very happy that it all ended up in one place, and it's like very accessible for me during streams. But I wanted to pick some filament. Yeah, why not? We talked about the Novofill. Let's use the Novofill. I know you can use pins like the beeper pin LCD slots for RGB. Yeah, exactly. Like my understanding is you can use any pin for RGB. So I would be surprised if it doesn't work. But they definitely have they do have power. You see like here there's like this random green section. So it's not a power issue. Check. Okay. Let's slice something small. Does the RGB port not send data on or off? No, it's like so for the RGB LEDs, you usually have like 3 pins. You have 24 volt or 5 volt or 12 volt, which is the power. You have ground, and then you have like a data pin, but it's not like it's a communication protocol basically. So you can individually control all the RGBs, and it's basically like a data stream that the controller sends out to program each LD to a certain color. That's also why if one LD is faulty in the center, the entire behind that LD, everything else is dead if the data isn't processed by that one. Like it's actually a microcontroller in each LD. Okay. Shall we just do like a mini Voron cube? Let's try that. Scale it down a bit to quarter size. Let's go for prototyping. It doesn't cut off a lot of time. Tiny Voron cube. Let's go. The model? Which model? Oh, you mean the bat? That is quite easy. You just go to the printer settings and then printable area, and then you say model, and then you can load like a STL file, and you can find them. Oops, that's not what I wanted. I think you have a Trident, right? I think most of them are on printables. Oh, okay. Well, okay. Maybe that's the wrong search term, but I know mine was from printables. V0 bad model. Oh wow. Well, sorry to disappoint. Yeah, you can export from cut. There's some magic with the positioning. Ah, here. This one, for example, should work. See here? That's 350 Trident, but yeah, still, you get the gist. So basically, you can import that and then you have it. The other thing you can do, which is quite cool, but like for me costs a bit of trouble, is you can load a texture here. And the texture, I have it on my Ender wire. You see here, there's like this Ender switch wire texture Voron logo thingy going on. And here it's just the model and the texture. So basically you can also load the bad texture. And then it looks more like the real printer. See here, don't have anything. Wait, didn't I print? I hit print. I'm very certain I hit print. But I see nothing printing. Ah, okay. Oh, it says, yeah, warning. It says just warning here. Acceleration's too high for some reason. I think I most like just changed some stuff. Um, no, it doesn't send it actually. Let's see. Yeah, I still have to like improve this arm a bit. Very sad. Yeah, this is really stupid. Like that's why I also don't move it anymore during stream so much. Because like once you move it, like it's a bit of a risky game. Let's see. It should start printing any second now. 108 out of 110 degrees. Cancelled. Okay, cool. Beeper is not valid. Yes. Let's make sure that the temperature is not falling because we want to, of course, resume that. Macros. Beep. Where beeper is not valid. So somewhere in macros, it should say beeper. Printer. Ah, yeah, here the M300. I'm just gonna comment this out. So we are beeping, but we're not beeping. Okay, second attempt. I really like the new cable with the sleeve. Like I think that's quite a good improvement. Let's see if we have success now. One more degree for that. Why does the Toolhead light not turn on? Oh, it's a very small Voron cube. And the first layer is definitely a bit off. I would say let's print it full size. Yeah, as a small test, it should be fine. It won't turn out very nice, I think, because the first layer is already a bit screwed up. Let's print it full size, but like, let's not print the whole thing. Um, so the first layer is way high. Oops, let's first cancel. The extruder makes a little bit weird sounds when doing the retract move when pausing. I mean, I'm just winging it now, 75 down. Looks okay-ish. It's a bit slow. I have a suspicion. Yes, there's a very annoying bug in Orca, and I don't know why that affects me, but it randomly sets the max flow rate of some filaments for me to 2. I have no clue why it does that. It doesn't change any other setting, it's just the filament. But then this results in very slow printing, which is very annoying. Let's try again. I'm really not sure. Like I checked Orca for like bug reports and that, but it didn't find anything. It's just like for me, like randomly it sets the max volumetric flow rate to 2. Playing with the fire here. Yeah, now the first layer is a bit low, but definitely better than before. I had like really nasty clog in like this is a Revo high flow 0.4, and I had a really nasty clog like last week. Like something was clogging the nozzle, and like it came out as like spiral, like the filament came out as spirals. It was really weird. And I tried hot pulls, cold pulls, and nothing helped. And then at the end, I used like one of the acupuncture needles, and I ramped it up the high flow nozzle, which E3D says you shouldn't do. It was the only thing. Like I spent almost an hour like trying to unclog that stupid nozzle. That was the only thing that like I didn't try. So I tried, and it helped. But it was a really nasty clog. And it's like quite annoying because they're obviously quite expensive, these nozzles. And like if you lose a nozzle to like like a clog you can't remove, like it's quite a bummer. My info looks a bit weird. Info looks really weird. Yeah, something's a bit off here. Something is a bit off. First, I don't have a camera. Oh, yes, yes, yes. You know what's off? The part cooling fans don't work. I was like, something looks a bit mushy. Like this completely overheated. The part cooling fans don't work. Okay. We didn't check that, to be fair. We did not check that. Uh, Fan 70%. Okay. Let's have a look. We said the part cooling fans are in the center, so it should be on PA0. Mm, so let's look for fan. EBB fan 1. Oh, it's the wrong printer. um, fan. Um, Fan GPO 17. Hot end fan GPO 18. Yeah, no, that's not correct, right? That should be EBB PA0. Did I remember correctly? PA0. Yes. Let's double check quickly that the port is correct. Nope, it's the not PA0, it's PA1. 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 Save. Firmware restart. Print. Oh, now I have a webcam. Ha, step by step. We could have tested the fans now before starting to print, but you know. I just set the fan to 13, so basically as soon as it starts printing, I expect the fan to start fanning a bit. So you should also start immediately. If you use Z-Hop, how much do you use? I don't use Z-Hop. I only use Z-Hop on top surfaces and 0.2 or something there. Try to avoid using Z-Hop as much as possible. I do enable it if I have very delicate parts that are prone to tipping over, then I enable Z-Hop to prevent that. But besides that, don't use Z-Hop. That's my recommendation there. That's actually awesome. And we have a firmware restart, so that's reset the Z, of course. Reset, I don't have working fans. I don't see fans working. EVB PA1. What fan is this? Because we have fan hot and fan, and we have fan. The controller fan is the one in the back, but like, what is fan? Oops. Oh, this is the hot and like the. Oh yeah, I'm a bit stupid. This one is the. This one is supposed to be PA0. This one is supposed to be PA1. This is the part cooling fan. This is the hot end fan. The hot end fan is plugged in the center, and okay, so it's random that just like works. Okay, stop. I edited the wrong printer again. Shit. Stop. This says fan 1, fan. I don't know what it just edited. I will find out eventually. Let's close this tab because this tab is cursed. Oh, I switched back and okay. I edited it here. So PA0, PA1. Let's double check that I plugged it in. Well, I think I plugged it in. So the center one is the hot end fan, which is 0. So that should be correct. Did you do the hot end fan also? Yes, I did both PA0 and PA1. So seemingly, fairness. Yeah, see here. There I said it. I don't know. Like this is the LDO config. I didn't change the config a lot. Like they really have a really weird way of doing that. Let's quickly see. Okay, the hot and fan is working. But no, we don't have working fans. The fans are not working. Let's check again. So, fan. So we have the heater fan, which is PA0, that seems to work. And we have PA1. Do we now have any more fan stuff here going on? This I commented out now. No, that's it. So I would expect the fans to work. No working fan. Let's do the following. Let's quickly shut it down. Let's switch the two fans that we see if it's wait. That we see if it's a config issue or if it's a hardware issue. Could be a bad crimp. Because I re-crimped these. So we know the hot end fan is working. Can I? Cable's quite... Yeah, it's a bad crimp. I don't have to even look at that. For at least for one, it's a bad crimp because there's a cable coming out. But for the other one, let me see if I can plug this in and kind of like prevent this cable from touching anything. Don't do that at home. So technically this should now at least have one fan spinning. One fan should be spinning. But there's no fan spinning. The hot end fan is also spinning at the moment. And we plugged them in and hot end fan. So there is a hardware issue for sure. Positive, negative. I think we double checked that. And I think it might be wrong actually. You might be onto something there. Yeah, that's wrong. I think that's wrong. Mm. Yes. Yeah, that's the wrong way around. That's the cause. Oh. And this screw did not get easier to reach with this new like toolhead mod. I think you definitely need an Allen key for that. Yes. Now we also have like extra screws here. Okay. Yes, that's wow. Ooh, shit. The stepper is super hot. We need to check the config of the stepper. It also looks a bit unhealthy here with the. You see, like there's a bit of a bend. I think that's really because the stepper is like cooking hot right now. You need to check what's up with the stepper. That is not correct. Okay, one step at a time. I almost fear I have to reprint this plate. Like looking at this, now you see like how it's bending here. I think it's because the stepper got like really hot because that was definitely not before. Oops. Okay, let's one thing at a time. Let's first try to fix this. Is there something I should have changed from the stepper settings? Okay. Well, that's the end of this one. Yeah, I think I got fooled because there's a bit of red here on that ground cable from when I pulled it apart. I think I saw that and then like that fooled me a bit into putting it the wrong way around. Mm-hmm. See if I can. Do this. Well, it's like dangling there a bit. Good thing we have strain relief. Yep, I think I screwed this one up. Okay, let me quickly completely detach that. I think that makes my life a lot easier. Now it's also easier than ever before. Okay. That's the reason why I don't like crimping 2-on-1. Yeah, this again like not good. Let's see. Another shot. Yeah, no, it's good. Okay. Then 5-volt bottom. And the ground pin top. Let's put the part cooling fan again in the center, not part cooling fan, the hot end fan in the center. And carefully, because quite short, part cooling fan here on the side. And I think this should have. Oh, I did it again wrong. This is classic me. At least make sure that the crimp is good. No, it's not good. Okay, we can confirm the crimp is not good. Amazing. Back to start. Back to start. Let's just say it's not getting easier here. Every failure, the wire gets a bit shorter. I think I never had a stream where I had to crimp so many double wire JC connectors. I absolutely hate it. What happened? The part cooling fan was incorrectly wired. I swapped positive negative, and now I'm again trying to crimp two cables in one JC connector, which is not going great. And the motor, the extruder motor, is like super hot. So we need to check the config there. Yeah, I think this one is okay-ish. Let's not do this again, please. So I think I bent the pin a tiny bit. I think we have a success. Just don't touch it. um, yeah, I'm so a bit concerned about the gap here in the extruder. Like it definitely like there's a quite a big gap here and here and here. And I'm not sure if that was before. That's definitely a bit weird. I mean, it's running smooth, so who am I to judge? Let's keep it for now. Oh, and the ah, I cut the heat shrink a bit short, so now the okay, that's another point of improvement. Okay, let's put it back together. I'm not typing anything yet. Let's just first check if the fans work. Damn, yeah, that's what I thought. So close of having like one stream without massive fuck up. While this is booting, let's quickly check that config that we have here. So let's copy this one. EBB can PA 15. I don't think we edited that. The TMC 2209. Let's look for that. Yeah, here. Again, like how would that work? I'm really confused. Um, I assume the run current 0.6 is fine because I had it the entire time. But now I'm just really confused how that extruder worked at all if like the stepper was misconfigured. So most that's the only thing. Okay, let's give it a shot. So first let's check the fan. I have two working fans. We have working fans, so yeah, that was it. Let's check the extruder. So let me just quickly heat it to 240. Let's also put the bed back up to 110. And I think can be optimistic. So I'm just leaving that open for now. Let's just quickly check that extruder is extruding. So if I extrude 50, oh, it's actually putting it in. So extruder seems fine now. Yeah, okay, let's give it a shot. I'm really confused how the extruder worked at all with incorrect configuration. But it was definitely extruding, and like kind of like in an okay manner. Let's give that Voron cube another shot. As I said in the beginning, like I kind of want a working printer after the stream. Let's see. Yeah, it takes a second now to heat up again. Let's see. I'm optimistic. Yeah. But guys, I think like in like about 10-15 minutes I do a hard cut. So whatever we have now, that's it. Like we're approaching now 5 hours of streaming. I did not expect this to be like this long of a stream. So it's treat it as the last attempt here. I'm very curious to see, but I think like now everything should be working. And the only thing like for next week that we need to check is the bad lights. Might also like just be like stupid mistake like with the fans. And I would reprint like on the back there this plate because we do have like quite an ugly hole there, right? So that's not super nice. So these two things I would redo. I'm pretty sure somebody else has like a nice V0 plate there with a strain relief or something. I mean, the one we have, it technically works. It just like has a hole. I don't like having holes there. Let's see, almost there. 100 degrees on the bed. We need 110. One or three. Always takes super long if you wait for it. It's still quite hot, the motor. I think the amps are quite high. Like 0.6 for such a small stepper is quite something. I mean, I never checked before if the motor is hot or not. Yeah, run current is 0.65. No, 0.6. It's defined twice. It's also fun. Um, Maybe I'll just reduce it to 0.4 or something. No, now it's super high. Let's quickly try this one more time. Yeah, every time you take the tool on and off, like it always like completely changes the setup set. Yeah, it looks better. Like for roughly winging it, I think this is good enough. Hold current, I don't know, but I also like I never changed the extruder config here. Like this is what it is since like 2 years. I do not have a hold current. I do not have a hold current. But yeah, I'll check the config here, but it's yeah, for later. I think it's getting quite warm. Like not as warm as it was like when roasted before, but it's still quite toasty. And I think now like with cooling it looks a lot better. Turns out you actually need those fans. Yeah, lucky it was only the fans that were like swapped. Like for other parts this could have been like a bit worse. Yeah, I think no, everything looks pretty good. Yeah. Now the walls are all crisp. Did you save config after you moved last time? What do you mean by moved it last time? I didn't. Like we removed the run current 0.65, which is duplicate from here. But I didn't save config after because we were like already in the print. So I would now let's just put this down to 0.5 just for the safety. And then just keep it like that. I think I remember seeing this comment here like from LDO. And I know that I checked that I have the second one. That's how I use quite a high current here. But yeah, let's just take it down a notch. We also, of course, have to run input shaper again. That's something I have to do later. Now it's super easy because we don't need this stupid white cable anymore. Set offset. No, I didn't save set offset. Because also we like took the toolhead off again. Um, so at the moment it's minus 150. I can save that for later. Yeah. Now it looks crisp and nice. And just yeah, it's toasty, but it's not cooking. So if we put it down like 0.1 amps, just like to get a bit more in the comfort level, comfort zone, should be fine. Oops. Okay. For some reason lost connection here. Why not? Okay, but I think I would use this like eighth of the Voron cube. Um, let's take a look at this. But I think it's fine. Like we didn't change any hardware related things, so this looks all crisp and nice. Like the first layer ignored it, like there's a bit of elephant's foot now, we're still too low. But the layers are stacked very evenly as before. We have very nice overhangs. The only thing that I noticed, like with this filament, like I'm still tuning that in. You see, like here on the inside, I'm not sure if I can focus this. Yeah, see here, there's like this one, yeah, here, like on the, when it does like the overhang with a inward, like an inward curved arc. Like sometimes the filament doesn't quite stick to the wall. There's pretty sure something with my slicer settings. But I noticed this with this green filament here quite a bit. Not quite sure if it's like, maybe it just means it's a bit too hot or something, or not hot enough. Um, I still have to play around with that. But generally, I think we are at a point where we should be. I save config, Steve. Um, so yeah, I would call this a 95% success. We lost our bad lights in the process. I still need to check what's up there. It's most likely something with pin, or yeah, that this pin is not capable of doing that. But yeah, so I would use this as a cutoff point. We successfully converted to canvas. For next time, I will print this little like holder thing here on the back. That we can like replace it with a nicer one. Should be quite quick. And then next time we will work on the Toolhead mount with the CNC part. And somewhere over here, I have this beautiful pack, which is a PC probe. So we will swap the heatsink on this one, which is the normal Revo heatsink, with this beauty here, which then will allow me to seamlessly switch between this build plate and the powder coated build plate in there. And I don't have to care about Z offsets anymore, which I think is like a very nice thing I was dreaming about for years, basically. So yeah, that's it. So this Revo heatsink will go to some other project. So I had to buy like one anyways, and the PC heatsink is actually not that much more expensive than like a normal standard Revo heatsink. So that was an ideal opportunity. Or check your retracts in Orca and make sure you're not overworking it. Yeah, might be, but like it's really like specific to this filament. It's really specific to this filament that I have this problem here with the. Oh, you mean for the motor? Might also be. Yeah, I'll play around with it. It's just like first time I noticed it now, so I'm not really sure. I'll just have to try out a couple of things and see what is the cause. Well, as he said, good night all. Thank you for tuning in and see you next week.